Hello everyone, this is Vaishnavi Ranbare. I'm currently in third year of engineering. Short introduction about me. I have been member of VLabs Digitizers since 2020. I'm mentor and student trainer at VLabs. I have participated in Bhuttathon Knockdown the Lockdown too. I'm one of the team member in the development of Trigonometric Analysis Lab. I'm also certified by IIT Bombay for HTML, C, CPP and Arduino. Now I would like to introduce Honorable Professor R.G. Kaduskar, Director of PVG COT and GK Pativani Institute of Management. Honorable Professor R.G. Kaduskar did MS in Electronics and Control from BITS Pilani, Rajasthan in 1994. Sir also did ME in ENTC in Government College of Engineering, Pune in 2000. Sir was awarded Adarsh Shikshak Puraskar from Dadaji Vaishnav Trust, Kalyan in 2004. Sir was also awarded Best Technical Assessor for 2006 and 2007 from Capit Cummins. Sir has received Best Jury Regional Award from Institute of Engineers and Technology, Bangalore in 2013. Sir has special recognition in Wipro Mission 10X program. Sir has received Cambridge Certified Teacher Trainer recognition with Outstanding Grade O. Sir has got special recognition from Chief Editor Bioinformatics Journal. Sir was consultant for IDG Microelectronics, Mumbai for two R&D projects in RFID. Sir has 15 national publications, 8 international publications and 5 IEEE journal. Sir has worked as resource person in many faculty development activities. Sir has written 9 books in engineering. Now I request Honorable Professor R.G. Kaduskar to say a few words.
Very good morning to all. Honorable Chairman of Pune Vidyarthigriha, Sri Sunil Redekar, Chief Guest of this event, Honorable Dr. Santosh Narona, Principal Investigator, Virtual Labs, IIT Bombay, respected Sri Pushpadeep Mishra, Project Manager, V Labs, IIT Bombay, In-charge Principal of the College, Professor Dr. Manoj Taramule, Principals, Deans, Head of Departments of various participating Polytechnic institutes, Regional Coordinators from MSU Baroda, MIT Marathwada, D.Y. Patil Institutes, Navi Mumbai. Our institutes, V-Lab Regional Coordinator, Professor Mrs. T.S. Kataukar, Professor Manish Nagoshe, organizing team members from V-Lab Nodal Centers, Vidyalankar Institute of Technology, Mumbai, AISSMS Polytechnic, Pune. On behalf of all the regional coordinators of V-Labs and nodal coordinators of V-Labs, I, Professor R.G. Kaduskar, on behalf of the V-Lab Regional Coordinator of PVG COT and GKPIOM Pune, extend my warm welcome to each one of you present online to this virtual lab outreach workshop. Dear participants, it's my proud privilege and pleasure to brief about our college, Pune Vidyarthigriha, that is PVG. It is celebrating its 112th glorious years in education and social field. It has a legacy of hardship, pursuit, commitment and determination to serve the society in educational area. PVG COET and GKPIOM, formerly known as PVG COET, is based on the solid foundation laid down by its great visionary, and we have PVGians committed to satisfy stakeholders through excellence in engineering education and creating multidisciplinary platforms for overall student development. College was established in the year 1985 with printing engineering program. In subsequent years, additional 5 engineering programs, namely mechanical engineering, electrical engineering, electronics and telecommunication engineering, information technology and computer engineering were started. College is presently running 2 postgraduate programs in electrical engineering and printing engineering. Also, college established research centers for 3 programs in electrical engineering, printing engineering and mechanical engineering. All these programs are approved by AICT New Delhi, DT Mumbai, and all are affiliated to Savitribai Phule University. In the coming academic year for this 2021-22, college is starting new engineering program in artificial intelligence and data science. As a part of quality education, college received recognition and accreditation from NAC Bangalore twice, with the recent accreditation as A grade in second cycle. 4 engineering programs of the college are accredited twice by NBA New Delhi. I feel proud to state that college is having recognition from various industries, to name few: TCS, IBM, KPIT, Texas Instruments, Atlas Copco, Avery Dennison, Dassault Systèmes France, Omnova Solutions, USA. Also, college is having good interactions and collaborations with reputed organizations such as DRDO, IIT Bombay, Maharashtra Energy Development Agency MEDA, Maharashtra Non-Conventional Energy Producers Association, All India Federation of Master Printers, that is AIFMP, National Digital Library India, which is an MHRD initiative, Indian Society of Technical Education IST, Institute of Engineers India IEI, and IEEE USA. College Training and Placement Cell is doing a great work regarding improving the employability of students. Special MOUs are signed for enhancing the student performances and increasing their employability opportunities. Even individual departments are encouraged to support training and placement activities. By this, they are inculcating soft skills among students from second year onwards, which is an integral aspect of curriculum. Even programs for interviews, group discussions are organized by college as well as department independently. I am very happy to mention that our college training and placement cell did excellent work by placing more than 290 students from this academic year in spite of COVID-19 pandemic situation and having a very large scale of scarcity of job. A very spacious and well designed library, full equipped facilities, and all the books, volumes, international, national level journals, e-journals are there. It is one of the unique feature facility of the college. College is well equipped with setups, infrastructural facilities, and various latest trends technologies, best initiatives to strengthen the quality education at all levels. College is having Wi-Fi campus with complete ERP solutions to all the admission process and administrative process. Even college provides foreign language training support from first year itself. Up till now, more than 28 students got placed in Japan through Asia to Japan language program. Thus, college provides training in German, Japanese language along with regular curriculum and is planning to have additional 2 more languages, namely Spanish and French. High qualified faculty with ideal blend of experienced senior faculty as well as young teachers is our strength. Faculties are motivated and continuously keeping themselves updated through various faculty development programs. Participating in various workshops, seminars and conferences, presenting papers in highly reputed journals. The supporting staff is also well qualified and motivated. Even non-teaching staff is also more enthusiastic and helpful. College day-to-day academic activities as well as disciplinary activities are regularly monitored and maintained with strict norms. Because of wholehearted contribution of college teaching and non-teaching staff, an equal response of our students, their parents, and good support and acceptance to our students from the industries, PVT, COET and GKPOION consistently maintain the quality of education for last so many years. We are all experiencing COVID-19 pandemic situation for more than 1.5 years. In spite of this, Through various collaborations and activities under such challenging situation, college maintains its academic standard, which is possible only with the support from industries and other experts from the industry. It is also the active involvement of and participation from our faculties, students, parents, which makes this entire academic program successful in spite of the COVID-19 pandemic. I wholeheartedly appreciate each one of them for their excellent contribution. This event, Virtual Lab Outreach Workshop, organized by PVG COET and GKPOM, VLabs Regional Center Pune, in coordination with Virtual Labs IIT Bombay, Regional Centers MSU Baroda, MIT Marathwada, DYP Navi Mumbai, as well as Nodal Centers VIT Mumbai and AISSMS Polytechnic Pune, is yet another academic activity conducted for benefit of Polytechnic students. I am sure that all teaching staff participating from various Polytechnic institutes will receive good inputs and will create interest in them so that they will be actively associated with the virtual lab development. Their active participation and creativity will enhance such development, which will be beneficial to the students of Polytechnic and other engineering streams. With deep sense of appreciation, my heartiest congratulations and best wishes to entire organizing team and their office bearers. I am confident that this workshop will be successful. Once again, I welcome you all. Thank you.
Hello everyone, my name is Tanvi Tarkunde and I am a mentor at VLabs Digitizers. A short introduction about myself. I have successfully completed the audit course for Virtual Labs. I have been the member of Virtual Labs Digitizer Forum since 2020. I have been certified by IIT Bombay for HTML Advanced CPP and Python 3.4.3. Now I would like to introduce Professor Santosh Noronna sir. Sir has obtained his BTech in Chemical Engineering from IIT Madras and subsequently a PhD in Biochemical Engineering. He was then employed as a postdoctoral fellow for several years at NIH Bethesda. He has been at IIT Bombay since 2001. He is a biochemical engineer by training who has evolved multidisciplinary interests. He has focused on understanding various metabolic and regulatory aspects of microbial systems towards rationally manipulating their productivity using genetic engineering techniques for production of therapeutics. Among other activities, he has focused on reactor optimization strategies for bioprocesses and on developing algorithms for online adaptive control. This has resulted in an open source indigenously developed bioreactor platform. This focus on indigenous instrumentation has extended into the creation of low-cost virtual laboratory rigs as well as healthcare devices. He coordinates development and deployment of virtual labs and MHRD ICT project. He is also professor in charge of the Tata Center for Technology and Design, an interdisciplinary center with a focus on creating solutions with a high social impact. And he also is the coordinator of the Healthcare Research Consortium at IIT Bombay, which interfaces with major hospitals and research labs in the Mumbai area and is now actively engaged in translating several collaborative research efforts into technologies. Now I would request Sir to say a few words.
Inviting me to this event, and what I intend to do through what is obviously a long, day-long event, explaining how to go about both deploying virtual labs but also creating your own virtual labs. I hope to give you a sense of history here as to what's happened, and also a feel for some of the pedagogy which is important in terms of how you engage and utilize this content in your own specific programs. So I hope to share my screen.
Yes, sir, your screen is visible.
Yes, so let me go to full screen mode. Yeah. So, as was indicated, Virtual Labs is a program funded by the Ministry of Human Resources, and it's been something which is a counterpart to NPTEL, which all of you, I'm sure, are familiar with. So, the intent has been that between NPTEL and a collection of interactive simulators called Virtual Labs, that there be enough free content available to students across the country so that they can self-learn. And there is a long-term vision that MHRD has of creating an online open university for which there has to be high-quality content, which is both created but maintained. So before I get into the nitty-gritties of Virtual Lab, we actually need to step back and think about what are the reasons we actually carry out lab experiments, especially in an engineering university context. There are two broad reasons to my mind as to why a good experiment works. And that's basically because you're either testing a theoretical concept or else you're being made familiar with some real world hardware. So look at the first point there. There's theory that's usually taught to us in some theory course, but invariably we end up seeing the counterpart of that as a lab experiment much later in our whole academic program. We typically at IIT Bombay see that corresponding lab experiment 1 semester after a theory concept is taught. The problem with that is there's no immediate reinforcement of learning when the theory is taught to you. And in an ideal context, you learn a bit of theory and you immediately test it out in some interactive fashion, ideally at some physical apparatus. And if you can't do that, then you do it at a interactive simulator. But the moment you do these things side by side, you're in a situation where your learning has gone to a different level because you have essentially reinforced applicable those theoretical concepts are. The other scenario is that of training engineers to move out into the real world and play around with the real world hardware. And most of us will acknowledge that the lab experiments that we run in our typical of various kinds, which allow for people to play around and collect of money. The things that we play around with are not real world systems. We play with the very robust lab systems, given that large numbers of students have to, as batches, undertake these experiments. In some situations, like for example, with the training of pilots or surgeons, there's just no ability to do real lab experiments all the time. You can't be, for example, surgeons cannot be practicing on patients or even cadavers all the time, which is where you need simulators. And those simulators, on the other hand, have to be very realistic in design. So you'll realize that most of the physical labs that we undertake as part of our regular curriculum don't address either of these two things in a good fashion. And when the virtual labs program was started by MHRD, it was to test out various ways of creating content and looking to see if you could broadly improve the pedagogy of what is being taught and therefore the retention of those concepts and steadily get a generation of students familiar with the hardware as well. Just to throw in a few slides about pedagogy, I do believe you'll learn more about this later in the day. Most of what students address is at the bottom of this pyramid, where most of their understanding and applications are tested in a lab at best. What you ideally want to do is to have students aim for learning objectives which address the highest levels of learning, which is where they get to create something or evaluate something or analyze a unknown situation, and then try to better appreciate a set of theoretical concepts. So at IIT Bombay, for example, one of the things we are trying to do is to get to the point where we offer student teams access to a storeroom of hardware components and let them build their own lab experiment from scratch, generate data, analyze the data, and then dismantle the rigs and put them away. And that's the ideal way of doing it. Obviously, it's a very expensive way of doing it, and it cannot be done for each and every concept that needs to be taught. But in the longer term, that's where lab instruction ought to go. So the problems, of course, with most engineering colleges that we have issues with the funding. We have issues with the ability to give quality instruction. Equipment typically is not available. If it's available, it's usually doubling up as research equipment. tends to be expensive. We tend not to use or run those experiments which have a dependency on consumables, reagents, and so on. And we tend to stay away from those kinds of experiments where there are safety issues for the most part. And so therefore physical labs by design end up being imitations of what ought to be actually taught. So when the virtual lab challenge was given to us by MHRD approximately 10 years ago now, the basic idea was that you could replace a physical lab. Well, for that matter, you could also attempt a physical lab or a simulator, but all of this would be accessed through the internet. The physical lab concept came about because, for example, MHRD realized that at the IITs, for example, the undergraduate labs are being used for 3 hours in a day in the afternoon between 2 to 5 p.m. And most of our equipment is idle beyond that. And so the question that we were asked is, given the investment in putting up these labs, is there a way for us to make these labs, put these labs online 24/7 and have other students access it, including taking experiments remotely? And of course, as you can imagine, our own students love the idea of taking a lab experiment in the middle of the night by logging in and then running apparatus and generating data. But the broad idea that we steadily started working on was how to test out various lab delivery concepts, either as remote triggered labs or as simulators. And one of the things you very quickly learn is that a remote triggered lab is an expensive proposition for two reasons. One, at the end of the day, only one student is accessing hardware at a time remotely. And therefore, you cannot train too many students, even if you make these things available 24/7. And there's also the risk that some of these things can be damaged as apparatus if you let the student try out too many things online, which means your design of the physical infrastructure has to be very robust to prevent abuse through the internet. The programs that we attempted basically can be broken down into three categories. We looked at how to come up with modeling and simulation labs, where these are simple interactive animations through which students learn. Then we had measurement-based labs, where we actually did the sets of physical experiments, collected data sets, and then we started feeding these data sets as if they were simulated data sets through the net. So the advantage here is the student gets to see some realistic data, and therefore gets to understand some of the inadequacies of the theory, because the theory always assumes perfect data. And the third category of things that we tried was looking at what would happen if we remote triggered hardware and let people learn through this mode. To give you a sense of what the simulation and animation experiments look like, there's a range of experiments which are created by a range of partners, and you can see that they all have different looks and feel. The top left, you're trying to see a bioreactor being run, and you get a sense that the interfaces are reasonably realistic in how essentially you have to flip different switches and execute different things in the reactor. At the bottom left, you're seeing much simpler protocol in a microbiology lab of how to carry out a sequence of steps for transferring organisms from one place or one flask or tube to another. And on the right, you're seeing, again, a bit more sophisticated way of getting things done in terms of looking at a fluid mechanics kind of concept. So you can see that there's a whole emphasis on artwork and interactivity, and also in terms of providing a good quality overall experience to students. I'm going to very quickly step through a sequence of slides, giving you a sense of how we went about this for a simple chemical engineering lab. This is a fluid mechanics experiment. And if you look at that panel on the left, it is listing a whole bunch of things that you normally would anyway see in a lab manual. There's the objective of the experiment, there's a theory, there's a procedure, there are some questions that you would normally ask in a while. Essentially, as of initial iteration on virtual labs, just took the physical lab manual and we tried to convert the physical lab experiment into a simulator. Now, one of the things that happens when you do that is you'll realize that there are serious limitations to the existing lab manuals. For example, when you're online, you really want to get a sense of to what extent people have read the content and are able to do anything. So the pre-test, post-test becomes critical for you to design to gauge how well somebody has understood the simulated interaction. The other thing that we quickly realized is while a physical experiment may last, for example, 3 hours, and that's a typical lab session at IIT Bombay, the interactive simulator, of course, can be done in minutes or seconds, which means you are forced into designing a lot of activity as a workflow online if you are going to keep students engaged for a window of time. That forces you to hit them with higher levels of questions, the higher learning that I talked about earlier. And the whole challenge is one of how do you keep people busy for 5 to 15 minutes, which is now the equivalent of a lab session online, okay, compared to the 3 hours. So the 3 hours, if you think about it, in a fluid mechanics experiment or a heat transfer experiment in engineering, is because students are waiting for some steady state to arrive, some measurement to stabilize, and so on. And there's a lot of wasted time in between as they're sitting around waiting for something to happen. And you don't have that in an interactive simulated environment. So because the theory is already coded in the background, there are computations which happen immediately, and very quickly you arrive at some conclusions. So examples of the pre-test, forcing people to answer these things before they can move on to the simulator, giving them exposure to the theory itself, not assuming that they've read it somewhere else. Notice that this is very bare bones in terms of an interface. We're asking people to try different settings to generate different flow rates, and then from there, so they start things, they watch these things. So this is an example of a lab experiment which is not a real world, realistic kind of thing. On the other hand, it is a very simple interface, and what the advantage of that is, this is accessible to students on even a phone, and it is not a heavy, bandwidth heavy kind of experience for a student. The phone thing becomes important because you've got to appreciate, especially in the time of the pandemic now, that a large number of students are trying to access content through a phone, and they're not at desktops, they're not necessarily at laptops. So some of the stats that the virtual labs program is seeing is that approximately 50% of access of virtual labs is via a phone, which means you've got to design user interfaces which are phone friendly, so that people can click buttons, do things, and collect data and so on, and then do further activities with this. So in this case, there are pressure drops being measured and computed, and flow measurements being computed, and so on. So that's a simple interactive experience as a standalone experiment. But then when you look at what teachers want a complete learning management system, which is something like a Moodle or a Coursera or an edX kind of interface. They need to find a way to integrate this into their curriculum, and ideally want it as a free tool. And over the years, what you realize is different instructors are using the interactive content in different ways. Some are directly replacing the physical labs, the afternoon labs, with a collection of virtual labs. Some have started incorporating virtual lab experiments into their Moodle theory courses itself. So as I said earlier, the best scenario is you teach somebody a little bit of theory and immediately ask them to play around with a virtual lab. So in which case the virtual lab should be accessible via Moodle itself, right next to where the student sees the theory video. So the MOOC, the concept of a MOOC itself is now changing into being a highly interactive experience where you see and learn theory, and then you immediately play around with an interactive simulator, and then you go back and learn even more theory, and you keep going this way. For all the people who are involved in using this content and creating new content, it is clear to us that their understanding of the topic improved dramatically. And the basic thing here is, if you're trying to keep people busy for 15 minutes and you're designing some activities which will keep them busy for 15 minutes, you're forced, when you're doing these things online, into teaching them some basic theory and then adding some advanced work elements, so that they're kept fully occupied, given that all of these computations are nearly instantaneous when they're done through a computer online. From a student's perspective, obviously, at IIT Bombay and later on the other colleges, students were extremely happy to just play around with computers and do lab experiments from a computer interface. Physical distances are no longer the issue, and the quality of learning has obviously improved. Most importantly, they managed to do this at their own speed and at their own time. And increasingly, several of them have gotten into a mode where they're evaluating their own learning skills. So the MHRD program for the last 10 years has involved 11 partners. It's led from a funding perspective by IIT Delhi, but essentially what happened is each of these 11 entities you see here broke off and created a zone around itself. That's simply because of logistical reasons, given that the mandate was that we create content, but also spread this content and understand the usage of this content. So IIT Bombay, of course, as you can imagine, is in charge of the Western region. Despite the fact that there are multiple partners in the program, the decision was made that everyone goes through a common front end. So students should not be confused with content coming out of different places. So there's a single login. All the content for the moment is free. And different developers therefore contribute into this common pool of content. Early on, so towards 2009-10, 10 labs were created or were mandated. We created more. We then got into a phase where we created many more simulators. Then the focus shifted from creating content to now asking how do colleges actually get down to using it. So the focus became outreach from 2014 onwards. But in parallel, more content needed to be created because obviously there were gaps in what was being created relative to the university syllabus. We essentially teamed up with a few of our nodal centers and elevated them into being regional centers. PVG is one. And we have got some participation from additional institutes in Mumbai, Aurangabad, Delhi. And we are already at a phase where 110 experiments have been developed by the community in a very short window of time. 110 is relative to the 1,400 experiments created over 10 years. So this is the way to go. So the community coming forward to create content, learning what it takes to create content, and then solving its own problem is the way to go. And it's something that I would urge you to participate in and explore, not just today, but down the road in trying to figure out what you need. And we will be there to help you along the way. So just putting up some list of the names of the experiments which we have created. That you can see they are typically in the computer science and electronics area, but we have things in the physics and biology domains as well. We're running workshops and boot camps, and that's simply because it's easier for us to, rather than hold several events online one after another, it's easier to pull a bunch of people together at one place and get them to focus and concentrate, especially when it comes to creating content. So there's now a process where there's a high energy kind of event where a number of faculty and students are brought together to try and brainstorm and then create content. So we've done this at several places, including one recently at UP. But the most recent one, in fact, is a boot camp that we've run through the lockdown. So which I list at the top. So well, so it's over here. We've run an event through the lockdown and attempted to create a large amount of content, given that anyway, faculty and students during the early part of the lockdown had time on their hands to sit and look at encoding some of this theory as interactive simulators. There's a team of instructors which are steadily evolved, and I need to acknowledge them because these are people who have given a large fraction of their time towards helping others create content. And so they're turning into a group of mentors in content creation process. Lots of students have also devoted a lot of time. And that's something else that we have come to realize. We really need to be harnessing the energy that the students have in creating this content. And it's about mentorship, telling them what to do. And usually they go and do a great job of it. There are two tracks now of how we do this. One is before the boot camps happen, we spend time with the faculty in webinar mode, bringing them up to speed on the basics of pedagogy and how to essentially, like like you would in creating a movie, you need to create storyboards. So you literally have to force people to visualize what the activities inside a virtual lab, and you create storyboards, and then you get them to essentially put down their thoughts, and from there convert it into small tasks which involve coding. Then separately, we work with the students to bring them up to speed on all the technologies which might be relevant for creating interactive simulators. For example, if you're creating a highly interactive animated content, then you need to be familiar with HTML5. We ideally want things access to browsers as content, and so JavaScript and TypeScript become important. Then you start putting all of these together, the faculty and the students. And the way it works, you don't necessarily put together students from one department in here. What you want is diversity of skill sets in a team. So the faculty could be from, let's say, chemical engineering, but the students could be from computer science and so on. Maybe you have one or two students from chemical engineering as well. But between them, they have enough skill sets to put down the theory of what has to be created. And they also have the coding skills, whether it be the browser user interface or whether it is the back-end simulator itself for evaluating the theory online. And we then get into figuring out how to evaluate students online, because one of the challenges here, as you can imagine, is how do you grade people who are doing virtual labs. There are challenges also with how to make sure your content can be some amount of trouble, because there are different ways people want it hosted. Some people want it running off a central server on a cloud. Some people want it running on a college server. And some people are happy with downloading the code and running it on local software. So in the bootcamp, we had a large an effort to reach out to a large number of participants across a large number of cities. And in some ways, this is the way to go. The usage stats for virtual labs, as you can imagine, and MHRD has been very curious about this. It's gone through the roof during the pandemic, with numbers of people, including international, because nowhere in the world has there been this quantum of content creation. In fact, we've even had the Chinese come in and try to access the virtual labs content created through the MHRD program. We have a lot of content which is housed on a platform called Git, and the idea is this is an open source code maintenance platform. And the idea is, as people create virtual lab content, the next team which comes along to create content should not have to learn everything from scratch. Maybe you can borrow bits and pieces of code and bring them into your own experiment design. That improves the thing for the whole community. That speeds up development for the whole community. So we've been working on creating platforms for code maintenance and development. So there's a certain process for how content that's been created goes national. So there's, at this point, hopefully you're clear that there are two programs afoot. There is Virtual Labs, which is the content already created by the IITs and already available for use. And then there's a new content being developed. We're calling that VLab Dev. So when new content gets created, it doesn't automatically become accessible to the entire community. We actually take it through a review process very systematically, through peer reviewers and then domain reviewers in particular. And once we're convinced that the theory is all correct and that the basic bugs have been pulled out, we are in a position now go host the content online. And one of the major advantages for a college to do this is you get international visibility because you get branding of the content that you create. The only insistence we have is that this all be free and open source to the student to use. The team structure that I talked about, the faculty with students of different disciplines and so on. And the process has been refined so that we are able to condense it down, given that people have a lot of demands on their time. So there's a lot of effort where we train people in advance on various things through webinar mode. And then when a physical event happens, it's done typically over a period of 4 to 5 days, where we get down to the creation of content as opposed to teaching them the basics of content creation. And we even try to get a review of the content developed happening in real time, so that there's real-time feedback to the teams. And we have started the certifying teams which are creating these things. So we're looking at different models of fast tracking these things, getting colleges to fund their own content creation bootcamps, looking at universities to get engaged in mandating the usage of this. As was implied earlier, AICTE is going to mandate that 20% of lab experiments be now done virtually. And this will continue post the lockdown itself. So we're looking at how to bring out better labs, and the moment you create a lab, there are ideas of improving the pedagogy, improving the user experience. It's like creating a video game. You create one thing, then students in particular, are looking for the next most challenging thing to do. So how do you improve the level of content and get more and more people engaged? There's more emphasis on the bootcamp sessions itself and on certification of developers and on the review. You'll find a lot of this detail at these links, which I'll just quickly flash through, but you'll be able to access this from the slides that I'll leave behind for use later. Where is the Virtual Labs program going? We're looking at an open platform for a large number of developers to contribute and looking at doing more of these events nationally. Technology-wise, we are trying to do this entirely through browser and cloud-based simulation, and the phone becomes an important user interface. And we are trying to build technologies which will allow for this to integrate into a MOOC platform. So Moodle is not designed for use of virtual labs. So at IIT Bombay, we have been investing through the data center that I run on a platform called Bodhi, which is a Moodle replacement. And we hope to find or build functionality to integrate virtual labs into the Bodhi framework so that students can go back and forth between theory and interactive simulators. There's going to be improved functionality in terms of authentication of students and validating it's the right student taking the experiment. That's because evaluation becomes critical down the road. How do you get people to start an experiment, pause it, go do something else, come back and resume the experiment? How do you have persistence in this? And we're trying to build in functionalization. And how do you make sure that no two students back to back get the same virtual lab user experience? Because then, for example, when you're grading them, they're just going to cheat. So how do you therefore randomize the various computations that they are going to have to do? And how do you give them different settings, random settings, and force them into doing slightly different experiments so that each student has their own unique experience? We're looking at incorporating the best pedagogical practices and frameworks for creation of storyboards, and you'll hear more about this. There was brief mention about augmented reality by the VC earlier. We're looking at that, but that's at the high end of the spectrum because that's very intensive in terms of what it takes a student to experience. But the other thing that can be done is as more and more students take virtual labs, we start learning a lot from the analytics. So for example, the way a strong student takes a virtual lab is different from the way a weak student takes a virtual lab. A weak student goes back and forth, for example, looking at the theory, coming back and trying something on the simulator, and they waste a lot of time. And if you just simply start paying attention to the time they're taking on an activity, you start learning whether somebody is going down the right track or not. And what that means is you can actually personalize the lab experience to a student. And we're playing around with these as features. You can actually give hints to students as they start taking an experiment and you see them start to struggle. And you don't need a teaching assistant online to tell them to do this in real time. We hope to create more regional centers and recruit more nodal centers, so that helps with the further rollout effort and run more events. And we also expect to start creating content for Polytechnic colleges and for the science colleges. A last thought on this. At IIT Bombay, we started with rollout. We focused on the creation of new simulator labs. We are shifting focus back to the creation of hardware labs as well, because at the end of the day, you cannot be teaching a generation of students on how to understand stuff through just simulators. They ought to see the real thing at some point. So how do you get them to now look at real apparatus, and how do you design experiences around a real apparatus? And therefore, how do you create low-cost hardware experiments to play around with? That's the next generation of things that we hope to engage with. And many of the kids who get into building their own hardware immediately get excited to work with us on innovation challenges. So we have realized that the reason to get into virtual labs is not simply teaching, but that in the longer term, there's so many great things we can do, the talent that we have around us. To give you the connect details at IIT Bombay, do get in touch with us if you wish to learn more about the virtual labs and the vLabs effort. And the organizers of this event will obviously also be accessible to you if you wish to learn more.
Hello everyone, my name is Dhruv Bhogaukar. Let me start with my introduction. I am a second year engineering student at PVG COET and GKPIM. I am a mentor at vLabs Digitizers. I have been certified by IIT Bombay for the completion of HTML training. I have worked as a resource person for the national event on web development held at PVG COET and GKPIM. Now, I would like to introduce Honorable Professor Urmila Kalchetti ma'am. Urmila ma'am completed her MTech in Computer Engineering. Talking about ma'am's professional experience, ma'am has over 16 years of teaching experience. Ma'am is the Nodal Technical Coordinator for VLab PVG COET and GKPIM from 2018. Ma'am developed the virtual lab Introduction to PHP, which is currently hosted on VLab Dev portal. Ma'am has organized various VLab outreach workshops in association with VLab IIT Bombay. Ma'am has worked as resource person for various outreach training workshops for faculty in association with VLab IIT Bombay in engineering colleges in and around Pune Pravaran Nagar. Now, I would like to request Urmila ma'am to say a few words.
Greetings of the day. I am Mrs. Urmila Kalchetti from PVG's College of Engineering and Technology. I am here to demonstrate you the lab Virtual English Communication Lab. This lab is developed by IIT Guwahati. You can see the URL for this lab on the screen. As far as MSBET syllabus is concerned, the first semester subject English, for this subject, this lab is useful. The practicals mentioned in this subject are mapping in the experiments of this lab. The various practicals based on articles, propositions, then listening skills and writing skills are for these practicals. The experiments in this lab are useful. Let us surf through this lab. We should go to vlabs.iitb.ac.in, then click on labs. Under these various disciplines, you have to go to the physical sciences. In the physical sciences, you can see this lab. Click on this Virtual English and Communication Lab. On the home page, you can see the list of experiments. Out of these experiments, let us first see the most mapping experiment with your practicals is grammar. All the experiments in this lab have these 4 options: theory, procedure, self-evaluation and reference. In theory, what this experiment is about has been explained. Procedure talks about how to use the self-evaluation. Let us click on the self-evaluation. Here the list of exercises have been mentioned. The exercises are on adjectives, prepositions, articles, and correcting the errors in the English sentences. Let us go through any one of the exercises. Now this exercise is based on the articles. You can see that there are 10 questions. 1 question has been displayed. Just click the correct option for this. The correct article I am choosing is A. You can see that if the answer is correct or wrong. Clicking on this next button, you will be able to see the next question. If you want to see all the questions at a time, just click on Show All Questions. You will see the list of the questions at once. Let us go to the next experiment. The other exercises in this grammar experiment are very similar to the one that we have seen now. We can see now next 2 experiments like business communication and technical communication. These 2 experiments are useful for improving writing skills of students. Let us go to the business communication. Click on the self-evaluation. There, we'll go through the 3rd exercise. Click on this exercise. You can see that in the left column, there are negotiation strategies listed out. And in the right column, we have various business situations. We have to just match the correct options. To match it, an option from the right column, you have to drag it to the left in front of the suitable option from the left. So I'm just doing it randomly. You can check if your mapping is correct. It is showing that this mapping is wrong. So you can ask students to go ahead to go on trying and getting the correct options so as to get the improvement. Now in the technical communication, Click on the self-evaluation. We'll see the second experiment, second exercise, which is concise equivalent. Here, there are 7 questions. A group of words have been given, and for this group of words, we can use a single word. Let me type a word, amend. Now I can check if it is correct or not. Yeah, it is correct. The objective here is, instead of using 4 words like this, I can just simply use a word amend in my writing or in my talking. So this way there are 7 questions. Similar to the previous experiment exercise, I can click on show all questions to see all the questions at once. The other exercises also you can make use of from this technical communication experiment. We can also have an experiment named listening skills. Okay, in that, now go to the self-evaluation. Here you can see the list of passages. All of these passages are audio files. Just click on listen, the audio file will run.
Nirupama quickly adapted herself to the routine life of...
So you can ask students to listen to these audio files, and then based on this, the questions have been asked here. Click on solve questions, you will see the questions. These questions are based on the passage which has been just listened by the students. So this way you can use it for improving the listening skills of the students. All these, among all these experiments, most of the experiments are mapped in one or the other way to the topics in your subject. You can see there is an experiment for vocabulary, there is an experiment for reading and comprehension as well. So you can make use of all of these experiments. Let me tell you about the way that we can use these experiments while teaching this subject. There are 3 ways that I come up with. Like, you can make use of. The first way is ICT tool. You can use it as an ICT tool while teaching the subject. The another way is you can make use of it as an assessment tool. You can ask students for sharing their screenshots of their answers to the exercises, and accordingly you can evaluate them. You can frame the active learning strategies on various experiments. I have listed out few of them. One is game-based learning. Treat an experiment as a game. Ask students to do the exercise. The scores will be available to you, and then you can declare the winners for this game. Another is rapid fire questions. As we have seen just now, that 1 question at a time. So you can ask students 1 question at a time, and by sharing your screen, and then you can ask them to share their answers, and you can have the clicking on the next questions, you can have these rapid fire questions. Next 2 active learning strategies are probably on the experiments like listening skills. We have seen listening skills. On this experiment, you can frame these active learning strategies. So list of active learning strategies is not limited. You can have your own active learning strategy with the help of this particular lab. Thank you.
Hello everyone, my name is Tanvi Tarkunde and I am a mentor at VLabs Digitizers. I have successfully completed audit course for virtual labs. I have been the member of Virtual Labs Digitizer Forum since 2000. I have been certified by IIT Bombay for HTML, Advanced CPP and Python 3.4.3. Now I would like to introduce Professor Mrs. Ranjita Ghosh ma'am. She is an assistant professor at PVG COET and GKPIM Pune. She has been working as assistant professor in the Engineering Science Department of PVG COET and GKPIM Pune since 2009. She has a total teaching experience of 12 years. She has completed MSc in Physics in 2004. She has successfully qualified GATE in 2006 and NET in June 2007 and December 2000. She has also been awarded Gold Medal as University Topper in MSc and also in BSc Physics Honours. She has authored book on engineering physics for Nagpur University. She has also published a paper in the international conference. Her areas of research are environmental science and evaporative cooling. She has also handled various portfolios like first year virtual lab coordinator, anti-ragging coordinator, first year feedback coordinator, student induction program coordinator, eco club and science forum coordinator, Kirloskar Vasundhara coordinator. Now I would like Ranjita ma'am to say a few words.
Hello everyone. Today we will see how to perform physics experiment by using the lab. So I'm going to explain two experiments. So the first one is use of p-n junction diode to draw forward bias and reverse bias IV characteristic. So once we reach to this page, now we have to go to the discipline or select the discipline Electronics and Communication. Now under this Electronics and Communication, there are a lot many labs. Our experiment belongs to Basic Electronics lab, and in Basic Electronics lab, this is the direct link to perform the experiment. Now let us see where the second experiment is. The second experiment is on projectile motion. This belongs to vlabs.iitb.ac.in. Now here we have disciplines physical sciences, and in this discipline we have a lab called Virtual Advanced Mechanics Lab. The direct link to perform this experiment is this. Now let us perform the first experiment. So the first experiment is from vlab.co.in. We will reach to this page, scroll down, then we will go to this Electronics and Communication. Now as I told you, there are a lot of labs available here. Our experiment belongs to Basic Electronics Lab. So now once we click Basic Electronics Lab, we will get this page. Now we have to select list of experiment. So we can see there are a lot many experiments. So we have to perform this one, VI characteristic of the diode. So once I click on VI characteristic of the diode, I can get different options over here. So the first tab is theory. Here the theory of this experiment is very well explained. Now the next tab is procedure tab. Detail of performing experiment step by step is given over here. So it will be very easy for the student to perform the experiment once they read out this. Now the next part, let us see how to perform the experiment, that is on simulation. Now once I click the simulation, I can get different options. So forward bias silicon diode, reverse bias silicon diode, forward bias germanium diode, reverse bias germanium diode. So here silicon diode and germanium diode, both the options are available. So student can perform the experiment for both. They can compare. So let us perform the forward bias silicon diode. So now this is the page. Here first thing we need to select the diode here. So as soon as I select the diode, I can get the barrier potential reflected here. Now the next thing, let's complete the connection here. So this is the ammeter which has to be connected in series with the circuit. This is the voltmeter which is to be connected in parallel with the circuit. And let us complete the circuit diagram. Once the circuit diagram is complete, let us check whether this connection is correct or not. So I will click here on check connection option. So here message reflected is right connection. That means our connection is right. Now if there is a mistake by chance in the connection, here wrong connection will be reflected. In that case, we need to select on delete connection and redo the connection. So once the connection is correct, now our setup is ready to perform the experiment. So the first thing we need to do, we need to change the resistance value over here. Once the resistance is set throughout the experiment, we are not going to change it. The next step, the second part of the experiment, we will change this DC voltage and corresponding current and voltage value from this ammeter and voltmeter to be noted down here in the experimental table. So now let us change this value. So once I change this value, I will click here on the tab add to table. So once I click it, the value of current and voltage is reflected on this table. Now I further change the DC voltage. So corresponding current and voltage to be noted down in the experimental table as I click on add to table. So I just go on varying the DC voltage and note down this value by clicking the add to table option to the experimental table. Now once the reading is over, I click here on plot. This will give me the plot of my reading. So if I take the printout of this page, I will click this print option, and this print option can be used later on also while the submission by the student. Now let us see the next part, how to perform. So now the next part is the reverse bias silicon diode. So I just click on this. I will get just similar kind of page. I will follow the procedure. Select the diode. So reverse voltage is being reflected here. I will change the resistance, and now I will change the DC voltage and corresponding current and voltage through this diode is been noted here in the table. Exactly in the same manner, go on changing the value of the DC voltage and note down the value in the table. So we need to do till the end. So now once the value is complete, the table is complete, now we have to click on plot option. Again in the similar manner, I will get the reverse bias curve. So in this way, we can perform the first experiment. We can give different options to the student. They can perform with the different diode options here, and they can compare the characteristic of these diode. Now let us see perform the second experiment. So second experiment, that is on projectile motion, that belongs to vlabs.iitb.ac.in. So once we scroll down, I can see the different disciplines. Physical sciences, where our experiment belongs to. Now in this physical sciences, the virtual advanced mechanics lab. So I'm just going to click it. Now here you can see this is our projectile motion. Okay, once we click on projectile motion, I will get this page. Again, like previous case, I am getting the theory in detail here under the theory tab. Procedure tab will explain the procedure of the experiment in very much detail. Now the next tab is self-evaluation. So here in the self-evaluation tab, there are 5 objective questions. So it is expected that once the student understood this theory, they can able to answer this question. So this is a self-evaluation kind of tab. Now the next part is the simulation. So once we click on simulation, you will get the simulator which is available for us to perform the experiment. So now I will just maximize the screen. So this is how the setup looks like. Now we can see choose environment options makes us available to perform the experiment for different value of the acceleration due to gravity. So student can compare the effect of gravity on the motion of the projectile as well. Now the other parameters are velocity, angle of projection and cannon height. Now this simulation helps us to understand how the change in the velocity will affect the motion of the projectile, how the angle of projection or cannon height will affect the projectile motion. Now let us see. So first thing, we will set the projection angle to, let us say, 20 degree. Velocity, initial velocity is 35. Now I click on this fire. So I can see how this cannonball is moving. Now if I go on changing this value of the velocity and click on fire, I can get the idea how the motion of the projectile got changed. So for every reading, every option, I am getting a different line which will help us to understand how the velocity affects the motion of the projectiles. If I want to show the result, that is time of flight, maximum height and horizontal range, so I can click on show value of show result option, and as I change the velocity over here, corresponding time of flight, maximum height and horizontal range can be noted down from this option. So this is one way. By changing the velocity, I can measure all this. Now let us see, we can opt for the next option, that is change of projectile motion. projection, angle of projection. So I will erase all this, and then now I will change the angle of projection to note down this value. So I can see what is the effect over here. So by changing the different value of angle of projection, I can get the projectile path over here. Corresponding time and maximum height and horizontal range will be easily noted down from this show result column. Likewise, I can also see how the height will create a difference in the path of the projectile. So as we go on changing the height, we can see the range of the projectile goes on increasing. So in this way, the student can able to understand how these parameters affect the motion of the projectile. So this is a very good experiment where the student can able to see how to perform the different experiment in a different way. They can compare the values. Now I have explained both the experiment. I hope this will help us to perform the experiment using VLab. Now, thank you so much.
Hello all, I am Sahil Morankar and I again welcome you to this national level event. I am head of VLabs Digitizers Forum. I am also project manager and mentor in VLabs. I was team leader of robotics in medicine lab and developer in strength of materials lab. Also, I was the senior trainer in nationwide Knock Down the Lockdown Bootathon organized by Virtual Labs IIT Bombay. Being a member of VLab's Digitizer Forum since 2018, I have completed the audit course along with certifications for HTML, C++, Arduino, and Python by Spoken Tutorial Project IIT Bombay. Today, I would like to introduce Professor Anil Kumar Bhatgare sir, a master's degree holder from Bharati Vidyapith University, Pune. Currently, sir is working as assistant professor in Computer Engineering Department at Pune Vidyarthi Gross College of Engineering and Technology and GK Pate Vani College of Management, Pune, having a total of 14 years of teaching experience. Sir was the faculty for virtual laboratory developed for computer graphics, which has been added on VLab's national portal of IIT Bombay. Seeing the potential of this lab, the virtual laboratory developed for computer graphics has been added in SPPU syllabus for 2019 course, which made all of us proud. Now, I would like to ask Bhatgare sir to address and guide you all. Thank you.
A warm welcome to all of you. Today, I am going to discuss the virtual lab for the subject Computer Graphics under discipline Computer Science and Engineering. As per Maharashtra State Board of Technical Educations, under the program name Computer Engineering, for the semester 3, we have a computer graphics subject. For the same subject, the list of experiment that maps with the given virtual lab has been available on this official website. Following are the suggested VLab experiment which can directly map with the syllabus. So the first one is implement following algorithm to draw a line using DDA, then a Bressingham line drawing algorithm, then Bressingham circle algorithm, then a different transformation, then we can have even odd method to check the seed point of a polygon. In today's session, I will be explaining implement the following algorithm to draw a line using DDA. To access the different experiment, we have official website vlabs.iitb.ac.in. Click on to VLabs Dev. Here you will be having Explore tab. Under Explore tab, click on Approved Labs. Now here you will be able to see the subject Computer Graphics under the discipline Computer Science and Engineering. So I will click on Computer Graphics subject. To know the various list of experiments that are available, click on to the experiment. So these are the set of experiment. So some of the experiment directly maps with the syllabus. Now I will start to explain digital differential analyzer line drawing algorithm. So as we are aware that we can draw the line either using DDA or a Brescian. So it is expected that whenever we are going to draw a line, students need to know the basic theory how to draw a line, whether it is gentle slope or it is sharp slope. Once they are aware of the basic theory, we can go with the pre-test where they are expected to answer the 5 different questions based on the increment either along x-axis or along y-axis. So here let's discuss with first question. If the vertical line has to be drawn, then should we increment along x direction? So I'll mark it as a false. For a vertical line, it's false. So for rest of the question, I'm randomly marking as a true or false. If I click onto the submit quiz, the questions which are wrong will be shown with the red color, and if the question is correct, then it will be having a black color. So here student will be able to see that how many questions has been attempted correct and how many questions goes wrong. So this will be their score out of 5. Now I will be correcting those options. I'll try to submit the quiz again. Once the students are able to see that all the 5 out of 5 marks has been availed by the student, then they can go with the procedure. In a procedure, students are expected to know the basic algorithm, how the DDA algorithm works to calculate the length, to calculate the increment, and then repeat it. Once they are aware with the particular procedure, the most important part of the virtual lab is a simulation. In a simulation, we have a 5 different set of questions for a different experiment. Now for this one, we have a question like draw a line from 2,3 to 12,8 using DDA line drawing algorithm. So I'll clear the canvas first, so that whenever we are going to run the particular canvas for the next question, it has to be cleared. So we want to rasterize this particular line 2,3 to 12,8. So if we know the DDA line drawing algorithm, we can find out the length, we can find out the increment. So based on that value, we will be getting certain new x coordinate and new y coordinate. So this will be what my first x1 y1, and the last x1 y x2 y2 will be 12,8. I am randomly selecting the points which lies in between those starting and ending point. Now these are the different points which I have plotted. Now to check out whether our calculation is correct or not, we need to click on check coordinate option. So I'll click on check coordinate. So if your calculation is correct, those particular points will be marked using the green color. If your calculation is wrong, those points will be marked as a red color. So here 5, 6, 6,6, 7, 7 are not a part of a line. So hence they have been highlighted with a red color. I will again clear the canvas. Now if I click the point 2, 3, the next point is 3, 3, 4, 4. I am pointing out those particular point which has been calculated with the help of a DDA algorithm. Once we have the correct calculation, if I click on to check coordinates, we will be able to see that all those particular points which I have clicked have been marked with the green color. So all these coordinates will be highlighted towards the right hand side table. Now moving to the question number 5, I'll clear the canvas. Question number 5, the point is 7, 10. So I will click onto the point 7, 10. This is the starting point 7, 10. The ending point is 9, 1. This will be the ending point. So what we will do, we will follow the algorithmic steps of a DDA. We will calculate the new x and y values successively, and we will match out whether the calculation that we have with us is matching with the points shown in a grid. So here all these particular points 7, 10, 8, 9, 8, 8, 8, 7 will be highlighted. So this is what the expected coordinate that lies onto the line, and same has been shown towards a right hand side. So in this ways students are expected to solve all 5 questions and check out their appropriate answer. Once they have done with all the 5 examples, they can go with the post test. Now in case of a post test, as students are already aware of the algorithm, now it is expected that they should able to solve the problem and they should able to check out whether the point lies onto the line or not. So the post test is just the evaluation example using the DDA algorithm. I am randomly picking out the points. Okay, I'll submit the quiz. Okay, now here again it's like a pre-test. If you observe the points which lies onto the specific line, and if it is correct, will be written with the black color, and if our answer is wrong, will be highlighted with the red color. So it is expected that students need to go with all the 5 set of questions, and they have to check out the answers by submitting the quiz unless they are not having 5 out of 5 marks. So here I'll just correct it. The line 10, 10, 5, 10 will be rasterized. Which point will lie on the line? So obviously it will be having only x increment, no y increment. So I will map the option number D 6, 10. Now I will submit the quiz. So here your score will be changed to 5 out of 5. So in this way student will get awareness about the basic theory behind the particular experiment, the pre-test, what is expected to know before starting with the particular experiment, the procedure, that is algorithm, simulation, post-test, and the references. In the same way, we will be able to demonstrate all these 8 number of experiments. So if I click for even odd method, it will be having a grid again. It will be having a pre-test, will be having the procedure, will be having simulation with the 5 set of questions, will be having the post-test with the 5 set of questions. So likewise, student will be able to know the answer for each and every questions, and they can evaluate whether they understood the even or method or not. Thank you all.
Hello, I am Shravani, currently a third year engineering student at PVG COET and GK Pativani College of Management, Pune. I am a member of VLab Digitizers Forum since 2020. I am a technical head and mentor at VLab. I have developed experiments in robotics and medicine lab. I am a junior trainer at Bootathon Knockdown the Lockdown 2 organized by Virtual Labs IIT Bombay. I have been certified for HTML, CPP, C and Arduino by Spoken Tutorials, IIT Bombay. Now I would like to introduce Professor Mrs. Sangeeta Bavkar Madam. Sangeeta Madam is Assistant Professor in PVG COET and GK Pativani College of Management, Pune. She has a total teaching experience of 12 years. She has completed his ME in signal processing in 2013. She has published 2 papers in international journals. Her research area include digital design, embedded system, handling various portfolios such as virtual lab, coordinator, mentor coordinator, exam coordinator, girl empowerment cell coordinator. Over to you, Sangeeta ma'am. Thank you.
Hello everyone, I'm Sangeeta Bhaukar from PVG COIT and GKPI in Pune. I'm working as a virtual lab coordinator in the NTC department. Today I'm going to explore this electronics and telecommunication discipline lab, which experiment name is a microcontroller interfaced with display devices. 8051 Microcontroller and Application Lab developed by Vivekananda Education Society's Institute of Technology. Subject mapping in MSBTE is as follows. Course code 22532, program code Electronics Engineering Program Group. Program code is this DEJ, ETEN, EX, EQ, IC and IC. Then semester 5th, course title is Embedded Systems. We can use this lab as a ICT tools also for assessment of understanding, then also for that simulation of various interfacing circuits. Now we'll explore the lab. Go to the vlabs.iitb.ac.in. Okay, you'll see this page. Here, click on Explore Labs. Click on Upload Labs. Here you can see the different disciplines and their respective labs. Just click on the 8051 microcontroller lab. See, this is 8051 microcontroller and applications lab. Here users will be able to write a program and see the output across the peripherals interfaced with 8051 microcontroller. So to explore this lab, click on Explore. See here, this is the list of different instruments like microcontroller interfaced with display devices, microcontroller interfaced with ADC and DAC, microcontroller interfaced with DC motor. So just click on this first experiment, which is microcontroller interfaced with display devices. Here the left side, see, these are the different tabs are there: aim, theory, pre-test, procedure, simulation, post-test and references. So click on the aim. Here aim of the experiment is given: interfacing of 8051 microcontroller with various display devices. Then about experiment, see, this is the experiment related to that, interfacing of LED and 7-segment display. After completing this program, this experiment, student will be able to understand interfacing of 8051 and different display devices, and also students are able to write their own assembly language program for 8051 microcontroller. Okay, then click on theory tab. In this theory, all that related theory is given in this tab. See, as this experiment is divided into two parts: LED interfacing and 7-segment display interfacing. So in first part, all about that LED, their symbol, connection diagrams and interfacing diagrams are given, and in second part, the all about the 7-segment display is given. Okay, see, there are two type of connections: common cathode and common anode. So this is the theory related to that 7-segment display. Okay, so student can explore this information. Also some PDF files are also provided here. Student can also explore these files and they can get the more information about the instruction set, hardware and all about that 8051 microcontroller. Then click on the pre-test. Pre-test here to check the prerequisites of this experiment. Student can solve this pre-test and we can click on evaluate. So like that he will get the answers of this. Okay, then procedure. In procedure tab, see, step wise and with the screenshot, all that steps are get explained. Okay, we need to refer this procedure to simulate the program. Okay, so go to the simulator section to perform an experiment. So this simulator window get open. Then read all the instruction popping up from simulator window carefully. Okay, so this window get pop up, so we need to read this carefully and click on OK. Then third, click on show sample button provided below. Understand the interfacing diagram and sample code. Okay, so this sample program is available here. Just click here, so this window get pop up, and here student need to understand the interfacing diagram and this sample code. We can copy this sample code and we can paste this sample code in the text editor. Okay, so we can we can test the same program here. Okay, so or we can write our own assembly language program also in the text editor. Then select the appropriate port according to your code. So which port we are used in that code, in the code, that we need to select here. Okay. Then to check the syntax error on each line, debug option is provided. Debug option is there to check the syntax error. Then if your code output is depending on timing sequence, please use debugging function. It will show changes in output step by step. And to get the final output, run the simulator after debugging and assembling the code with no error. Okay. So run is there, so where the complete program will get executed and you will get the result. Here, solve the test questions given below the simulator section. After the simulation section, see there are some questions are there. Student can solve that questions and write down the conclusion and then submit the answers. Okay, after submitting, he will that PDF file is get generated. That here student can save with their roll number and external name, and they can upload this as a part of practical assignment. Then go to the simulation. Here simulation is there, simulation window is there. Here you can see the pin diagram, then memory part, then peripheral, and here this is the text editor area, where after that we need to click on this is the run and debug buttons are there, reset button is there. Okay, now click on show sample display. See this window get pop up. Here student need to understand the interfacing diagram, and this sample program is also there. So we can copy and paste this program. Okay, and in this interfacing diagram, all the basic connections are given: reset connection, crystal connection, ground, VCC, and that LED connection. On the same pop-up window, see this 7-segment program is there. So first we'll perform this and then we'll go for this experiment. Okay, so I have copied the code, just paste this here. Okay, now we can debug the code. The first line is set port P1.0. So port we need to see the, click on debug, port P1.0 LED glows, then P2.6 LED glows, then that P2.6 LED clears because clear P2.6 instruction is there, then debug P1.0. So it will clear the P1.0. Also we can modify the pin numbers. See, like if I see the pin number instead of P1, I can, so we can modify this code and we can also debug. So here P0.0 LED on, P2.6 on, then P2.6 LED clear, P0.0 LED clear. So like that we can modify and we can test our assembly language program. Okay, then see show sample program. We'll go to the next part. See, in the next part, this is the 7-segment interfacing diagram is there. All basic connections are there shown. Also the 7-segment connection is shown in this, and this is the sample program which we can copy and paste here. Okay, and we can debug the program. See here port 0 is get used in the code, so we need to ensure that here port 0 is get selected. If any other port is there, we need to select that respective port. So I'll keep this port 0, then click on debug. See here this is the code related to that. 7E is the code required to display 0 on the 7-segment display. Now how to find out this code, that all about this code information is given in the theory tab. So student need to explore that and they need to understand the program. Okay, so this is the program. Now we can just click on debug 0, 1, 2, 3, 4, 5, 0, right, 7, 8, 9, 10, 11, 12, 13 and 14, 15. That F is there. Again 0, 1, 2. So also I can change the port. So I will just change the few port, like a 1, only few instructions I am changing. So port 1. Okay, port 1. If you want to change the port, you can change it. Okay, so now we'll just, so we need to change this port 1. Okay, and we will debug it. Yes, 0, 1, 2, 3. Okay. So next instruction we cannot observe because for that we need to change the port like this. Now debug it. Yes. Now you can see the next results. So like that we can check the simulation here. So print simulation window, we can take the printout of this, whatever the program written, the pin diagram, everything, these things are available here that student can take the printout and they can submit as a part of practical assignment. Okay, then test is there based on this practical. This test is there. Student need to read all this instruction carefully. See, these are the types of questions, conceptual, problem solving, analytical questions are there. They can solve the test, write the conclusion and submit the answer. After submitting the answer, PDF is get generated and they can submit that PDF with their roll numbers as a part of practical assignment. After that, they can solve the post test. Okay, and they need to submit this again, and references tab is there. In that, book references and website references are given. Student can explore these references to get the more knowledge about this experiment. Okay, thank you so much for patience listening.
Hello everyone, I'm Mehak Gupta, a final year engineering student at PVG COET and a mentor at VLabs Digitizers. I am a member of Students Club PVG COET. I have also served as a junior mentor in Bootathon which was held in May 2020. I have also been into the development of heat transfer lab and 2-axis robot envelope. I have been certified by IIT Bombay for C++, Arduino and Advanced CPP. I have qualified Bootathon 2.0 and also completed the audit course of virtual labs. Today, we have with us Professor Mrs. Priya Deshpande ma'am. Ma'am is currently working as an assistant professor in Electronics and Telecommunication Department of PVG COET and GKPIM Pune since 2008. She has a total teaching experience of 14 years. Ma'am has completed her ME in Signal Processing in 2011. She has published 2 papers in the national conference and 1 paper in the international conference. Her research areas include digital design, VLSI design, and technology. She has handled various portfolios such as Virtual Lab Coordinator, Training and Placement Coordinator, Student Internships Coordinator, Telecommunication Engineering Student Association Coordinator, Assistant Students Development Officer, Kirloskar Vasundhara Coordinator, Girls Empowerment and Development Coordinator. Now, I would like to request ma'am to say a few words.
Hello everyone. I am Professor Mrs. Priya Deshpande from PVG COET and GK Patewani Institute of Management, Pune. I work as an assistant professor in ENTC department and handle the portfolio of virtual lab coordinator. So today I will be demonstrating the digital electronics lab. I will be demonstrating 2 experiments: verification and interpretation of the truth table of basic and universal gates, and construction of half and full adder using XOR and NAND gates and verification of its operation. So this is the digital electronics lab developed by IITR. So below is the link to visit the lab. So this is the subject mapping in MSBTE. This lab is mapped to the course title Digital Techniques with the course code 22320, and it matches with the program Electronic Engineering program group, and the subject is in the 3rd semester of the syllabus. So this is how you can use this lab. So as in teaching learning process, you can use this lab as an ICT tool. So you can simulate various combinational and sequential digital circuit through the experiments given in the lab. You can assess the performance of the student, understanding of the students through the pre-test and the post-test MCQ quiz which are posted in the experiments. So now we will go to the lab and demonstrate the experiment. So you have to visit the website vlabs.iitb.ac.in so that it opens the homepage of IIT Bombay, where you have to select VLabs Dev tab. Then you select the Explore Labs option and select the approved labs. So in the approved labs, you find the list of disciplines and the corresponding virtual labs. So I will be selecting the digital electronics lab from the electrical engineering. So click on that. So it will direct to the digital electronics lab developed by IITR homepage. On the left hand side, you see the introduction, objective, list of experiment, target audience, course alignment and the feedback. So introduction gives you the welcome message. Objective of this lab is to learn and understand the basic concepts of digital electronics. If you go to the list of experiments, you will find total 12 number of experiments starting with the basic study of gates towards the implementation of the combinational and the sequential logic circuits in the digital techniques. So I will be selecting the first experiment and the second experiment for my demonstration. So I click on the verification and interpretation of the basic and universal gates. So on the left hand side, you will find the aim, theory, pre-test, procedure, simulation, post-test, references and the feedback. So the aim of the experiment to verify and interpret the logic and truth table for various gates. Then if you click on the theory tab, you will find the detailed theory about all the basic gates, their truth tables and their implementation using RTL, diode and register logic. So students can study the theory of all the basic and universal gates in the theory tab. Pre-test. So this is a pre-test conducted to be conducted before the simulation to check the prerequisite understanding of the students. So there are total 5 questions. So I will click on the random answers from the given options and I submit the quiz. So here the quiz is evaluated. Right now I have selected random, so I'm getting a score of 0. So students understanding, prerequisite understanding can be checked using this pre-test. In the procedure tab, you will find how to simulate the gates and truth table by using the simulator 1 and simulator 2. So follow these steps so as to perform the simulation. So next I go to the simulation tab where you can see the simulation experiments for all the basic gates and the universal gates. So I will demonstrate the AND gate. So on this top corner you can see the simulator 1 and simulator 2. So this is the RTL circuit for the AND gate. So here you can see this battery. So that is to be connected to the circuit. So if I click on the battery gets connected to my circuit. So this is the switch 1 which connects the battery to the rest of the circuit. So I will make this switch on so that battery supply reaches to the switch 2 and switch 3. So switch 2 and switch 3, they are used to provide the binary inputs to the transistors so as to verify the truth table of the AND gate. So on switch indicates 1, off switch indicates 0. At the output we have the LED. On LED indicates 1, off LED indicates 0. So right now both the switches are in 0 0 position, off position. So the output is also 0 indicated by off LED. I make one switch on. Again the output is of LED is off because this is an AND gate. AND gate gives output 1 only when both inputs are 1. So I will change the output, I will change the input switch to 1 0. Still I am not getting the output. And now I change both the switches to 1 1. I will make more switches on, and here you can see the LED is glowing, indicating that for both input combinations 1 1 the output is equal to 1. That verifies the experiment to perform AND gate on the kit. So this is the simulator 1. So you can go to the simulator 2 to check the truth table. So here in the inputs you have to enter the value, and in the output you have to enter the expected output. So if I enter a 1 here, a 0 here, my expected output is 0. So if I write a 0 and check, then in the truth table I can get the remark as correct. But instead, if I write a 1 and check, then in the truth table you will see that I am getting the incorrect output. So AB01, the output should be 0, but if I have written 1, then when I check this I am getting the incorrect result. So you can check all the binary combinations and the expected outputs, and you can have the entry in the truth table. You can print this and you can save this later so as to get the entire details of the experiment. So this is the first experiment. Now we'll go to the second experiment. But before that, let me go to the simulation tab again. So you can simulate OR, NOT, NAND, NOR gate, XOR gate, XNOR gate. You can explore all these gates. Once you do the simulation, there is a post test option. So understanding of the students about the experiment and the related theory is checked by using this post test. So student can select the options and submit the quiz, and the quiz gets evaluated. Then you have the references, where you will find the list of the books and some web resources that you can refer for the study. And then you have the feedback, where you can share your experience about performing the experiments in the lab to the virtual labs team. So now we'll go to the second experiment, verification of the truth table of half and full adder. So the format is same as that of the half adder, as that of the gate experiment. So aim of the experiment is defined. Then the theory of the half adder and full adder with their truth table, their equations for sum and carry is all explained in the theory section. So the forming of half adder and full adder using NAND gates and NOR gates and their realization using some Boolean expressions, the entire theory is explained in the theory section of this experiment. Then you have the pre-test, that is testing the understanding of the students before performing the experiment. Then the procedure, two simulators are given, simulator 1 and the simulator 2. So detailed procedure can be read and the experiment can be simulated accordingly. So now I will go to the simulation tab. So in simulation tab, you find the half adder and the full adder. So now I click on the half adder. So here is the circuit for the half adder, and it's here you can see the entries for the truth table. As I said earlier, the supply switch on indicates 1, switch off indicates 0, LED on indicates 1, LED off indicates 0. So first you need to make the supply on, so that IC will be getting the supply at the pin number 14. So this is input A, input B. So you have to verify the truth table for half adder, for sum and carry. So right now both switches are off. So the output is sum 0 and carry 0. So I can add that entry in the truth table. Now I change 0 1. I will make switch B on. So you can see sum is equal to 1, carry is equal to 0. Add in the option in the truth table. So now I will make input 1 0, and you can see again the sum is 1, carry is equal to 0. Now I make both inputs. I will add this entry in the truth table. Now I will make both inputs 1. So you can see here sum is 0 and carry is equal to 1. Add in the truth table. So if you click on the print, you will get the print of the circuit diagram and the truth table. You can save it for your further reference. So that is the simulation of the half adder. So in the simulator too, like the gate, you can give the inputs and you can predict the outputs and you can check whether they are correct or not. So suppose if I enter 1, then my expected output is sum 0 and carry 1. So I check it. So it is correct. So if I changing it to 1 and if I check it, then the result is incorrect. So this is the simulation for the half adder. So in a quick way, I will go to the simulation of the full adder. So this is the circuit for the full adder using 7486, 7408, 7432. So I will make the VCC supply to the ICs on, and here in the truth table you can see there are 3 inputs A, B and C in, and the outputs are sum and carry. So for full adder, if any one input is 1, the sum is 1. If 2 or more inputs are 1, the carry is 1. And if both inputs are 0, if all 3 inputs are 0, sum 0 and carry 0. So now I verify this truth table of full adder by changing the switch combinations. So here we have all the 3 inputs 0, so sum is 0, carry is 0. I will add in the truth table. Similarly, now I will make 0 0 1, so sum 1, carry 0. So add in the truth table. Next combination 0 1 0, sum 1, carry 0, add in the truth table. Then 0 1 1, then you have 2 inputs 1, so carry will be equal to 1. So here you can see the LED for carry is glowing. So add in the truth table. So then the combination is 1 0 0, 1 0 0, sum is 1, carry is 0. 1 0 1, for that carry is 1, sum is 0. So you can add that in the truth table. So 1 1 0, for 1 1 0, sum is 0, carry is 1. You can add that in the truth table. Last combination is 1 1 1, which is giving both sum is equal to 1 and carry is equal to 1. You can add that in a truth table. So this is how you can demonstrate the truth table, a full adder functionality, and verify the truth table using simulator 1. And again, in a similar way, you can go to the simulator 2, where you can give the inputs and write down the expected outputs in a sum and carry dialog box, and you can check it. So this is the correct one. So if I enter here 0 and if I check it, then it is giving me incorrect. So you can check the truth table of the full adder using this simulator 2 as well. So this is the demonstration for the full adder using simulator 1 and simulator 2. So now I will go back to the main page of the lab. And again go to the list of experiments. So I have demonstrated first 2 experiments. So I request you to explore this lab by going through all the 12 experiments that are designed in this lab. So if you see, the experiment starts with the basic gates and it proceeds further towards the implementation of the basic sequential and the combinational circuits formed using the gates. So I hope you have understood the simulation and how to use this lab. So I request you to use this lab for your course digital techniques, and I'm very much thankful for listening me very patiently. Thank you so much.
Hello everyone, I am Nehal Sharma, a third year engineering student at Pune Vidyarthi Grihas College of Engineering and Technology and JKPIM Pune. I am a member of VLabs Digitizers Forum since 2020. I am currently a project manager and a mentor in VLabs. I have developed 3 experiments of the chemistry lab. I have also qualified Bootathon 2.0 and completed VLabs audit course. I've been certified for HTML, C, C++, Arduino by Spoken Tutorial IIT Bombay. So today we have with us Professor Meenal Apsangi ma'am. Ma'am is an assistant professor in the Information Technology Department of PVG COET and JKPIM Pune. She has completed her ME in Information Technology. Ma'am have a total experience of 15 plus years. She is a nodal coordinator at VLabs PVG COET since 2018. Ma'am have developed virtual lab, introduction to PHP and digital logic design. She's also organized various VLab outreach workshops in association with VLab IIT Bombay. She has also served as a resource person for various outreach training workshops for faculty in association with VLab IIT Bombay in engineering colleges in and around Pune, Satara, Nashik. Now I would request ma'am to say a few words.
Greetings to one and all. In today's outreach workshop, I will be explaining the lab from the subject data structures. Specifically, I will be demonstrating the experiment based on sorting techniques. This lab is available under vlab.co.in and this lab is developed by IIT Hyderabad. So let me just open the Chrome window. This is the home page of vlab.co.in. Now you can just scroll down here. You can see various disciplines. You can select from here computer science and engineering. Under computer science and engineering, various labs have been developed. Now we are going for data structures lab. You just scroll down and you can go for data structures 1 lab, which is the newly developed lab by IIT Hyderabad. You can click on this. A new tab will open and this tab will contain all the information about this lab, which is data structures 1. Data structure 1 lab gives you the experiments like sorting, graphs, trees, stacks, queues, searching, linked list. There is another lab which is data structures 2, which gives you advanced data structures like red-black trees, etc. So over here, we are going for the sorting techniques. If you click over here, that is bubble sort, it will open the page for the bubble sort. Now over here they have given bubble sort as well as optimized bubble sort. Along with that, the detailed analysis for calculation of a time complexity of this bubble sort technique. It gives you the overview of that, and the most important thing is it gives you all the information in video format also. Recap just gives you a quick recap about the sorting technique. And if you go for the bubble sort, again over here you have tabs like aim, concept, algorithm. So you can see it is a complete manual for you available on this virtual labs platform. Under the concept, they have also given a video where a person is explaining how exactly this bubble sort works. Algorithm section gives you the detailed step-by-step algorithm along with the demonstration video. If you go for the demo, it gives you the actual animation of this bubble sort. If you click on this arrow, it gives you the instructions how you are supposed to use this particular demo. You can change the speed maximum or minimum, and you can say start. Once you say start, it will just highlight in different color, specifically yellow color, the two elements which are under consideration. So I'm just clicking on the start button. So you can see that the two elements under consideration, whether swap is required, which elements are getting compared, how many number of comparisons happened, how many number of swaps have been done till the point. All this information is given to you under this section, which is nothing but observation. So just for this demonstration purpose, I'm just increasing the speed over here so that it happens fast. And once everything is finished, what it will do is it will give you how many total number of comparisons and how many total number of swaps happen in the sorting of this array of elements using bubble sort. So you can see that every single iteration detailed they have shown with this animation. So you can see here it has given you the sort is complete. There were 72 comparisons and there were 20 swaps. So this is happening automatically, but there is another section which is called as a practice section. So you can go to practice section and you can check it out how exactly the things are going to happen. So I can just say, okay, this is a practice. So I can say 14 and 46. I don't need any kind of a swapping over here. So I can just say next. Now whether the student has understood the concept correctly or not, that we can find out from here, because the observations will give you whether the button you clicked is correct or not correct. Like for example here 46 and 85, as 85 is greater, there is no swapping is required. So if I say swap, it will give me incorrect, think again. So likewise, whether the student has understood the concept properly or not, that also I can get it over here with this particular exercise. Now exactly similar way we can just say next. Again a swap is required. Again there is a swap required. Likewise I can complete this demonstration over here. Now every iteration the student can perform like this. So it here, let's see here, it is giving me incorrect, think again, because both the numbers are same. I don't need any kind of a swapping because this is a stable sort. So we can just go ahead. I just need a swap. So in the first iteration I got highest number, which is 85, got placed at its proper position, which is nothing but the last position. Exactly on the similar basis, there are other tabs like a exercise. So if you just click on the exercise, it will open you a new exercise and it will tell you what you have to do. You can just give start. Again, it will give you whether you have to do next or swap. Accordingly, all the observations will be available to you over here. Now what happens is, even if the elements which are salt, or even if I have a salted data, this algorithm will still go on comparing the elements. So we can optimize this by using optimized bubble sort, and the detailed information about that is given over here. Again, you can see over here the similar tabs like aim, what is the optimization technique they have used. So all the detailed information is also given over here based on a video. You can go for again the similar practice session, or you can go for the exercise. So you can really come to know whether the student has understood this sorting technique properly or not. Not only just giving you the information about how this sorting technique works, but it also gives you the information about the analysis part of it. What is the space complexity? What is the time complexity? What is the stability of the bubble sort? And its comparison over other algorithms. all the detailed information about just one single technique is available over here, which is a bubble sort. In this experiment, they have just given the bubble sort exactly same way. There is a insertion sort, there is a merge sort. All these experiments are explained almost in the similar fashion. So you can see that it's a complete manual where under bubble sort whatever are the features are there, like its algorithm, like the practice, like the exercise, then its time complexity, space complexity, its optimization, everything is available at one place. So you can just open this and you can use this for your subject. Now the most important thing is we have the concept of slow learners and weak learners. So some part of this is not there in your syllabus. Like let's say optimization of the bubble sort is not there, or the time and the space complexity is not there. So you can give these kinds of readings or these kinds of exercises to those students who are very fast learners. So for this purpose also we can use this virtual lab as a tool even for slow learners or the fast learners. Now you can see that this subject, whatever we are talking about, let me just go to PPT again. So you can see that the subject is entirely available on our virtual labs. So I have just kept over here a mapping of MSBTE Computer Engineering Group and Information Technology Group. The subject is data structures using C, and the subject, you know that it is in the 3rd semester. Now all the experiments which have been mentioned in this lab or in this subject are available under virtual lab. So you can take a maximum benefit of it, and you can ask the students to use these labs for the practice purpose, for additional information, so that they can have the concepts very clearly understood. So that's it from my side. Thank you very much. Thank you once again.
Greetings everyone, Rajyasree Nilesh Thakre here. Let me introduce myself first. I'm a second year IT branch student at Pune Vidyarthi Griha, Pune. I recently completed the VLab audit course and I'm a mentor and trainee at VLab PVG COET. I also was a mentor for the National Web Development event held on 17 July 2021 in coordination with VLab. Along that, I'm also a member of other technical clubs like ITSA, EDC and Robotics. I have been certified in HTML and CSS course from IIT Bombay. Now with great pleasure, let me introduce you all to the head of first year engineering department, Professor Mrs. Anjali Suresh Wagmare. She got her BSc degree in chemistry stream from Shivaji University Kolhapur in 1994. Then MSc degree in polymer chemistry stream from Shivaji University Kolhapur in 1996. She completed her B.Ed in science and math stream from Shivaji University Kolhapur in 1997. She now has a teaching experience of 22 years and still counting. Her topic of interest in research is polymer nanocomposites. Talking about her remarkable work, she had presented a paper on algae, a superior alternative for production of biodiesel in National Conference on Chemical Engineering and Environmental Current Trends and Issues on 3rd and 4th November 2006 at the Institute of Engineering and Science, IPS Academy, Department of Chemical Engineering in Indore, Madhya Pradesh. She has co-authored the paper on biogas and marine board from waste green leaves in the International Congress of Environmental Research held at Gitanjali Girls PG College, Bhopal between 28 to 30 December in 2007. Now, over to you, Wagmare ma'am.
Basic Sciences, Semester 1, and another practical from Chemistry Applied Sciences. So if we see the list of the practicals, so from first semester we'll have demonstration of pH meter, pH values, and second semester determination of hardness by EDTA method. Now for this, we'll see how to go. Now in the search engine, type the vlabsiitb.ac.in. vlabsiitb.ac.in. Click on this. Yes. Now scroll down. Go for chemical sciences. Yes, chemical sciences. So now to see the exact experiment of chemistry, there are different branches. So physical, organic, inorganic, then click on inorganic chemistry. Yes. So now in inorganic chemistry, you will see that it has number of different headings. So to have the pH metric or pH values of unknown solution, we are going to go in detail of water analysis, determination of physical parameters. Now if you see the objective on the screen, objective is to determine the physical parameters, turbidity, pH, conductance. So theory is given related with this, procedure, self-evaluation, simulator, assignment, reference, etc. Now to perform the experiment, we have to go to the simulator. Yes. And then log in for this. The registration is the essential part. Okay. So I'll log in. Yes. Now the experiment will be uploaded on the screen. pH value determination of unknown solutions or different solutions. Yes, water analysis, physical, content. So I'll make it a full screen. Yes. Now on the right hand side, you see the different variables. That is, select the test, which what we want to test is pH value. So pH value. Now on the left hand side or on the screen, you see that pH value determination is done by pH meter, which is connected to the electrode, combination glass electrode which has two electrodes, that is glass indicator electrode and reference electrode may be calomel or silver chloride electrode. So they are dipped in water sample. Now before we note down pH value of a known solution, it is essential to standardize the pH meter. So in this virtual lab also, standardization part is displayed. For this we use different buffer solutions. So buffer solution having 4 pH, I'll select first. Two buffer solutions are given here. So I'll select 4 pH first and then the tab standardization. As soon as I click on standardization, it will show 4 pH. Okay. Then the next buffer solution, that is 7 pH. Then standardization, it shows 7. So simultaneously you can see that the water is or the sample. Now standardization is done, as you all know, by dipping these electrodes in distilled water. Now after standardization, the sample whose pH is to be determined. So the beaker containing it is replaced, assuming that now we are going for sample water sample. So if you want to find out the pH value of tap water, so I'll select the tap water, but still it is not showing any value on the monitor. So for that purpose, I have to click on switch on. So as soon as I click switch on, the monitor will show pH value as well as here we can see. Yes. So showing 7. Similarly here also it is displaying 7. Now go for next water sample. Suppose it is now well water. Then again switch on. Note down 8.4. So like that the values we can form a table and different water samples. Now distilled water I have selected, switch on, note down the pH in a tabular form also it can be done. Now next is seawater. So you can just compare it. Suppose seawater is there now here. Switch on, shows 7 point. So you can compare the pH values of different water samples. So this is about pH value determination. Similarly, you can have turbidity, electrical conductivity, etc. Now we'll go for the next experiment. For this, I'll just go back in inorganic only. Yes, water analysis, but now I don't want physical parameters. I have to perform the experiment of which one? Estimation of hardness by EDTA method. Okay, so now again coming back to inorganic chemistry virtual lab tab. There, first part we have seen one experiment, physical parameters. Now I'll go for chemical parameters. Yes, now the same things are displayed here, that is theory related with it, procedure, etc. And if you see the objective, to determine the chemical parameters such as hardness, alkalinity, COD, etc. Now from this I am going to demonstrate the hardness part. Even alkalinity is there for MSBT syllabus. So for this demonstration of practical, before simulator you can see the theory part is given. Now here in this experiment we can determine the total hardness by EDTA method. So temporary hardness, permanent hardness, ranges are given. Then the part, that is calculation part, you can see the color change also, before endpoint, at endpoint. So this is the endpoint, reddish pink to blue, and this is the formula in which calculation is to be done by substituting the values, that is volume of EDTA into molarity of EDTA into 100 into 1000 upon volume of water sample. Now I'll go for the simulator. I'll demonstrate you how to perform this experiment on virtual lab. Determination of hardness of water sample by EDTA method. Okay, now I'll make it full screen. Good. You can see even the labels. Okay, so now on the right hand side, there are, so you can see here, select which variable test you want to do, that is hardness, alkalinity or COD. Now I want to perform hardness or demonstrate the hardness part. Now in this, it's a titration, so burette is filled with EDTA solution, that is the volume of, the titrant EDTA which is filled in the burette, and in conical flask well water, so that volume of titrate is 10 ml. Now assuming that the beaker, the conical flask along with the water sample, a requirement of buffer solution and then indicator, that is eriochrome black tea is added, so the color appears reddish pink and constant stirring is being conducted. Now to perform this titration, well water is selected. I'll just keep this 10 ml as water sample. Speed I'll just increase. So instead of 0.1, I'll make it 0.5. Yes. And molarity, I'll keep it constant 0.01. So as soon as I start, the volume from this burette will be released in this, drops will be visible, and we have to continue the titration. Now see, I'll start it. Continue the titration till it becomes blue. As soon as it becomes blue, I have to stop the titration, and you can see the reading. Titrant use 1.1, 1.2. So go on adding till it becomes blue. Yes, it is pink still. So all, yes, stop. So now the drops also have stopped. So the reading is 2.5 ml for well water. Note down this. is V1 or V, volume of titrant added from the burette to get the endpoint. Then you can do the calculation in the same formula by substituting. Now, in the same manner, we can find out the ml of titrant. For this, what I have to do? For next water sample. So, I'll reset it. Again, it becomes reddish pink, assuming. Now, instead of well water, I'll select the next, that is tap water. Now, so tap water, volume of titrate, that is in the conical flask 10 ml, speed again 10.5, molarity 0.01. So here now it is showing that is titrant used 0 ml. So I'll start the titration and stop it as soon as it becomes, now it is tap water, so we can check that it may be little bit the hardness less than the well water. Yes, stop. So it is less than even 2 ml. So 1.6 ml. So Eriochrome black tea was added. So it was reddish pink turned to blue. So the color Eriochrome black tea is actually blue, which is obtained at the end of the titration. Now again I'll reset, and the third sample given is seawater. So assuming everything same, I'll just again increase the speed. Water sample was only changed. Now since it is seawater, maybe the hardness is a little bit more compared to bore. So as soon as you start the volume, it will start dropping from the burette solution, and when it turns blue, we have to stop the titration. Now EDTA being a strong complexing agent, it complexes with all the calcium and magnesium ions from this flask water sample, and when all calcium complexes with it, the color appears to be blue. So the color of the complex is actually colorless, and the blue color is of the indicator which has no choice. It has to show its own color at the end point. So see, it has increased even above 4 ml titrant use. So seawater we have selected, so maybe the hardness is more compared to tap water. And well water, how much it is? Yes, stop. So it is 6 ml. So like that we can substitute the values separately in the formulas and find out the total hardness, which will help students to compare the hardness of it. So like this we can even check for alkalinity, etc. So thank you all of you, and hope that you have enjoyed the experiments of virtual lab. Thank you.
Hello everybody, my name is Shruti Yadav and I am a mentor at VLabs Digitizers. A quick introduction about myself. I have been a member of VLabs since 2019. I have served as a mentor in Bootathon, Knockdown the Lockdown 2, organized by Virtual Labs IIT Bombay. Apart from being a mentor, I am also a student trainer and have trained numerous students in TypeScript and C++. I have been a developer for Fluid Mechanics Lab and Physics Lab and have developed various experiments associated with it. I have completed my audit course and am certified by IIT Bombay for HTML, Basic and Advanced C++, Python and Arduino. Moving ahead, now I would like to introduce Dr. Sri Devi Kulkarni ma'am. Dr. Sri Devi Kulkarni ma'am is working as an assistant professor in the Department of Biomedical Engineering at D.Y. Patil, deemed to be University, Navi Mumbai. She has completed her bachelor's in instrumentation engineering, her master's in biomedical instrumentation, and her PhD in electrical and electronics engineering and science. She is the regional technical coordinator for Raigad and Navi Mumbai region of VLabs at D.Y. Patil, deemed to be University. She has also participated in boot camp held at Marwadi University, Rajkot. She was a mentor for the Bootathon held at REC Banda and has been mentoring for the development of virtual labs till date. With this, I would request Dr. Sri Devi Kulkarni ma'am to say a few words. Thank you.
Hello everyone. I'm Dr. Sridevi Kulkarni, working as Assistant Professor in the Department of Biomedical Engineering, School of Biotechnology and Bioinformatics, D.Y. Patil deemed to be University. Our organization is being recognized as the Nodal Center and Regional Center for Virtual Labs in association with IITB, and I am the Regional Technical Coordinator. I welcome you all for the outreach workshop of virtual labs. Today I am going to discuss the usage of an experiment related to electrical engineering. The lab corresponding is sensors modeling and simulation lab. The experiment which has been chosen is characterize the temperature sensor RTD. The link of the experiment that is going to be explained is as given in this slide. This is the link of the experiment in virtual labs and it is developed by COEP Pune. The subject mapping in MSBTE is as follows. It bears the course code 22348 and 22335 with a program named Diploma in Medical Electronics and Diploma in Instrumentation/Instrumentation and Control. It belongs to the third semester and the course title is Biosensor and Industrial Measurement respectively. Now to begin with, let's navigate through www.vlab.co.in. So as we are going to click this, then we land up to a page. So this is the page of virtual labs, an initiative of Ministry of Education under the National Mission on Education through ICT. As we are going to scroll down, then we are going to get the objectives and broad areas of virtual labs. So we are going to select electrical engineering, the domain of our choice where the experiment is present. So I click on electrical engineering. Then we have ready to use labs in this list. Now out of this, we are going to choose sensor modeling and simulation lab where the experiment falls. Now this gives us the introduction and list of experiments regarding the sensors lab. So as I click on the list of experiments, then we are going to get a list of experiments corresponding to the sensors lab, like characterize the temperature sensor RTD, simulate the performance of biosensor, measurement of level in tank using capacitive type level probe, characterize the LBDT, design an orifice plate for a typical application, simulate the performance of chemical sensor, characterize the strain gauge sensor, characterize the temperature sensor thermocouple. Now out of this, I have chosen characterize the temperature sensor RTD for the demonstration. So when I click on this, then we get into the experiment characterize the temperature sensor RTD. Now on to the left hand side, we can see that we have a number of options like aim, pretest, theory, simulator, procedure, audio, video, post-test, review questions, references, photo gallery and feedback. Now when I click on aim, then we are going to understand the aim of the experiment, that is to understand the working principle of RTD, and then we have the objectives of this experiment, which is nothing but study of static and dynamic characteristics of RTD and study effects of various parameters on RTD performance. So there is something called as pretest, which is generally taken by the student in order to understand the amount of content which the student has understood regarding a particular topic. So this is the pre-test, which is generally taken before the experimentation using the simulator. So when I am just randomly clicking on the answers here, a random click on the answers, and then we have a submit button which has to be given. So once we do this, then I get the number of questions which I have answered right and the number of questions which I have not answered right. So I can either take the quiz again or I can view the solutions. So the student can do the same in order to find out whether he or she is able to answer these pre-test questions. Once the pre-test questions are done, then the student can get into the theoretical part. So the theory is going to deal with all the content that is required by the student to start with the simulator. Now, this is about characterize the temperature sensor RTD. So the prerequisites of whatever theoretical content the student has to understand is given here. Like it can be the meaning of the temperature, the electrical resistance and the formula related to it, temperature measurement using RTD, the formulas which are relevant for this particular thing, and the materials which are going to be used for the construction of RTD. Then the temperature calculations using a very well-known formula, that is RT is equal to R naught into 1 plus alpha T, where RT is the resistance at temperature T and R naught is the resistance at reference temperature, and alpha is temperature coefficient of resistance, which we are going to use even in the experiment. They have also showcased the graph of the RTD, that is temperature versus resistance, and then we have all these equations and calculations. Apart from this, we are also having the list of materials which are going to be used, and then we have these equations or understanding about the static characteristics like accuracy, stability, interchangeability, then the dynamic characteristics which are response time. So all these content are given in theory. So these are the prerequisites which a student has to understand before starting with a simulator. Apart from this, there's a procedure which is given. So this procedure is nothing but a step-by-step guide in order to use the simulator. The simulator experiment is divided into two levels, level 1 and level 2, corresponding to static characteristics of RTD and dynamic characteristics of RTD. So the procedure gives us a step-by-step understanding of the usage of the simulator. Now let's get to the simulator. Now as I click on the simulator, then here it shows click here for simulator. So when I click this, then I get a page of resistance temperature detector. This is the lab which we are going to work with. Now this is level 1, which is corresponding to the static characteristics of RTD. Now there's a figure which is showing us the RTD with its head, and the RTD is dipped into a solution where the temperature is going to change. Now on to the right hand side is the control panel where we can select the material, the R naught value, and then we can get the temperatures and calculate the values of RT and enter these values and look to the plot of this particular static characteristics. So here in the scroll, we are going to have different materials that can be used for the construction of RTD. Now I am going to choose platinum as the material. Once I choose platinum as the material, then I am going to get the values corresponding to this particular material, the alpha value and the temperature range. So the alpha value is 0.00385 and temperature range is about -200 to 850 degrees. Now apart from this, I can also choose the R naught value, that is the resistance at reference temperature. So here I am going to choose 100 as the reference resistance of the reference temperature. Now once I have chosen all the prerequisites, then I say get temperature. The simulator provides us with the temperature. Now we are going to use the formula and calculate RT value and then enter it here in the output. So the formula is RT is equal to R naught into 1 plus alpha T. Otherwise, we can click on this formula which gives us the information regarding the formula. So this is also provided in theory, and for reference it is provided here also. Now the temperature which we have obtained is 638. So I am going to calculate RT value 638 into 0.00385 plus 1 into 100. So I'm making use of the formula which is given, substituting the values, and then I'm going to input the value which I have calculated. So the student has to input the value which they calculate and then press the submit button. So if the answer is correct, then only we get this highlighted correct button. Otherwise, it asks us to recalculate. Now we get another value of get through the get temperature. So now we are going to calculate one more value, 135 into 0.00385 plus 1 into 100. So I get the value as 151.975, and I input this value and press the submit button. Since it is correct, it accepts this particular value. Then I get one more temperature value. So it is 742 into 0.00385 plus 1 into 100. So I'm going to input the value of 385.67 and then submit. We need at least minimum of 3 values for the plot button to highlight. That is, we are going to get the static characteristics, or we can get the plot of temperature versus resistance, which we have just now calculated. We can have many more values for the plot. A number of samples can be increased in order to get this plot. When I click on this plot button, then it gives me a graph which is going to be a plot of temperature versus resistance. So as I'm going to scroll on this plot, then I can see these values which I have calculated for various temperatures which was provided by the simulator. So this completes the level 1. So making use of this particular graph, we can calculate the static characteristics or understand the static characteristics of this particular sensor. Now we go to level 2. Now level 2 relates to the dynamic characteristics of the experiment. Now here we have different options available. That is, the first one is bare material, the second one is with sheath, the third one is with the thermowell. Now when I'm going to click bare material, then I have already chosen platinum to be the material. Now the time constant corresponding only to the material gets displayed, that is 1.17 seconds. This is the time constant. Now once we have clicked this, we are going to get the RTD which is being constructed using only a material, that is platinum. Now when we are going to select this with sheet, a sheet is going to get constructed along with a bare material. So this is shown in the figure besides. Now here we can select the type of the material for the sheet, and also the thickness of the sheet can be chosen, and we are going to get the corresponding time constant for this particular option. We can have different combinations provided so that we can understand the change in the time constant for these combinations. Now we have the next one, that is the thermowell. When we click on this, then a thermowell gets generated from along with the sheath, and now we can choose the type of the material which we are going to choose for the thermowell, and the thickness of this also can be chosen. Along with this, we have something called as the filling material. So we can choose the filling materials also, and we are going to get the time constant corresponding to this particular combination. So we can again change the combinations and then find out what are the changes in the time constant. So once we are done with the choice of all these, then we get a plot. This is the plot of the dynamic characteristics, that is the time versus the temperature. Now the blue line gives us the dynamic characteristic for the bare material, the green gives us with the sheet, and the orange gives us with the thermowell, and the yellow indicates the step input. So this is the way in which the response, dynamic response, is obtained for the dynamic response is obtained for the RTD. So by varying these combinations, we can find out different time constants which are available for RTD. Now, the flexibility of the choice of the material, choice of the sheath, choice of the thermowell, then the thicknesses and other relevant data is possible using virtual labs, which would otherwise not be possible in the regular labs. So this is an advantage offered by the simulator. And so we complete level 1 and level 2, that is static and dynamic characteristics of RTD. I hope I was able to help you understand the working of the simulator and rest of the parts. Now, once the simulator is done, we can have the post test. So this is the post test. Then the references, which are nothing but the topics or the books, useful links from which the material has been used for the this particular experiment. So I wish I was able to help you guide as to how to use the simulator for this particular experiment, and the same thing holds good for the other experiments also. So thank you for watching this video. Thank you.
Hello everyone, my name is Dhruv Bhogaukar. Let me start with my introduction. I am a second year engineering student at PVG COET and GKPIM. I am a mentor at VLabs Digitizers. I have been certified by IIT Bombay for the completion of HTML training. I have worked as a resource person for the national event on web development held at PVG COET and GKPIM. Now, I would like to introduce Honorable Professor Sheetal Chinkhede. Sheetal ma'am has completed her BE in Electronics and Power Engineering from VNIT Nagpur. She completed her ME in Electrical Engineering from Faculty of Technology and Engineering, the Maharaja Sayajirao University of Baroda. She specialized in Industrial Electronics. Talking about ma'am's professional experience, ma'am has over 23 years of teaching experience. She has been the lecturer for Department of Electrical Engineering at Polytechnic, MS University of Baroda. She has also been an assistant director for the Department of Computer Engineering at the Polytechnic, MS University, Baroda. She has also worked as a deputy director for the Office of Career Advancement for Student at MS University of Baroda. Ma'am is also the nodal coordinator for VLabs MS University, Baroda. Ma'am was also the mentor of change for Atal Tinkering Lab, nominated by Niti Aayog, Government of India. Talking about ma'am's research and publications, ma'am has over 6 international publications and 10 national publications. Ma'am has worked on research project Distributed Energy Sources and Switching Techniques funded by Research and Consultancy Cell, the Maharaja Sayajirao University of Baroda in 2013 and 2014. Ma'am is currently working on the project Impact of Climate Change on Energy Consumption Pattern Case Study of Vadodara City, funded by Climate Change Department, Government of Gujarat. Now, I would like to request Sheetal ma'am to say a few words.
Namaskar, myself Sheetal Chinkhede. I am Nodal Coordinator of Virtual Lab at the Maharaja Sayajirao University of Baroda, Vadodara. Today I will show you one experiment, that is verification of Thevenin theorems and how this can be performed using this virtual lab. During the period of pandemic, actually the virtual labs are blessings to academicians as well as students. So let us have a short tour of this virtual lab. Whenever you want to start virtual lab, type vlabs.iitb.ac.in. You will find this page. Then go to labs. There are various disciplines over here. I am going to select electronics and communication. In that I will select analog signals, networks and measurement. Here there is a tab, that is list of experiments. Go to this tab, open this tab, and then there are number of experiments over here. Out of this I am selecting verification of Thevenin theorem. There are again various tabs here: theory, procedure, operating environment, simulator, quiz, references. This theory, it gives you at a glance what is Thevenin theorem is. This I am not going to explain. This procedure, this is a circuit for which we are going to solve this circuit with the help of Thevenin theorem. This is RL and we will find out current flowing through this RL with the help of Thevenin theorem. This procedure actually tells you how to operate this simulator. Then operating environment means what you need for this, what are the minimum prerequisites to open this simulator. When you click on the simulator, here you will get a link to the simulator. Click here to perform the experiment. See, this is the experiment. This is the circuit actually, and here this is value of this is RL, and we want to find out current flowing through this RL. Here there are various resistors. You can solve this first of all and find out theoretically current flowing through this RL. Now how to solve this with the help of simulator? So there are steps given. In this case, this R, we can vary this R, okay. This R3 we can vary, R1 we can vary, R2 we can vary even this V2, okay. We can vary RL, okay. So all these we can change, even supply voltage we can change. So there are number of probabilities, number of observations. For the number of observations you can take, you can solve number of examples with this one circuit, and you can verify also. So what is given here is case 1. In the case 1, it is mentioned to get the load current, select switches S1 to power. See, here there is an option power, short and intermediate. So select this power mode, and S2, this is S2, and here we will select this in load mode, okay, and then simulate this. So you will get the value of current, okay. Now we will verify this with the help of Thevenin theorem. So case 2, when we want to find out current through any resistance with the help of Thevenin theorem, we will generally what we do is we open it or remove this, okay, and we find out VTH, that is Thevenin voltage, and RTH. So here are the steps given, okay. So to find out VTH, S1 is connected to power mode and S2, that is in the intermediate mode, okay, and then find out, simulate this, you will get VTH. Then another is case 2, that is to find out RTH. So for this RTH, what we say is, if there is a voltage source, short it. If there is a current source, open it. So since there is a voltage source, I will keep this S1 to short mode and S2 to power mode, okay, and then we will find out RTH. Third case, here is the circuit. This is called as Thevenin circuit, okay, where RTH, voltage source, and RL is there, okay. You simulate this. So whatever the current, you can fill this in the table. Here is the table given, okay. Load current from case 1 and load current with the help of Thevenin theorem, you can verify this. So you can take number of readings, you can solve this, and you can verify the result. So this is the way you can perform this experiment, where that is verification of Thevenin theorem. There is a quiz here, you can solve this quiz. Number of examples are given over here, okay. These are the options given, okay, and you can submit this, you will get the result, okay. Here there are references given, which book you can refer for this, okay. So and some NPTEL video lectures are also available. There are labs available. Another Labs also available like verification of Norton theorem, superposition, three-phase power measurement and so on. So you can go through this one by one, and I'm sure this will be very much useful to the students. Thank you.
Hello everybody, this is Pratna Gaikwad from Pune Vidyarthi Grih's COET and GKPIM Pune. A quick introduction about myself. I have successfully completed audit course of Virtual Labs. I am a member of Virtual Labs Digitizers Forum since 2020. Apart from being a member, I am also a mentor at VLabs Digitizers. I have been certified for HTML, Basic and Advanced CPP, Python 3.4.3 by IIT Bombay. Moving ahead, I would like to introduce Dr. Manoj Taramble sir. Dr. Manoj Taramble sir is in charge principal of our college, Pune Vidyarthi Grih's College of Engineering and Technology and G.K. Paटे Vani Institute of Management Pune. He has completed his bachelor's from Electrical Department as well as his master's from Electrical Control System. He has completed his PhD from Electrical Biomedical Image Processing. He has more than 27 years of academic experience and 1 year of industrial experience. He started his work experience from MS Suhas Engineering Work, Pirangut, Pune as an engineer from 1992 to 1993. Later, he joined PVG COET Pune in Electrical Department from 1993 to 2008. And then he joined MMCOE Pune in Electrical Department from 2008 till current date. He worked as assistant professor and at present he is working as associate professor. His research topic is in the field of biomedical image processing applied for detection of lung cancer in its early stage from chest X-ray image. His areas of interest are control system, analog and digital electronics, instrumentation, biomedical image processing, robotics, electric and hybrid vehicles, illumination engineering, etc. Till today, he has published 1 paper in national conference, 7 papers in international conferences, and 9 papers in international journals. His profession affiliations are: he is currently a member at Institute of Electrical and Electronics Engineers IEEE. Also, he is a member of Control System Society. He is a life member at Indian Society for Technical Education ISTE and International Society for Research and Development ISRD. He is a member of Quality Circle Forum of India QCFI and also International Association of Engineers IAENG. Till now he has visited Malaysia, Bangkok, Hong Kong, Macau, China, Japan, Singapore for technical paper presentations, program chair, conference general chair, to deliver keynote address and for academic purposes. He has been awarded with InterSciences Young Investigator Award of Information Technology and Computer Society, Bhubaneswar, India for the paper published in 2015. He has also been awarded with Most Excellent Paper Award for paper presented in Malaysia 2013 and Best Paper Award for the paper presented in conference held at MGI COET Shegao in 2018. His special achievement is he has delivered a speech in BIT's 8th World Congress on Industrial Biotechnology held at Nanjing, China in April 2015. His honors are he has delivered a keynote address on the topic of job opportunities and skill set required for entrepreneurships during COVID-19 pandemic situation in 8th International Conference organized by Universitas Negeri Gorontalo, Indonesia on the topic Creative Entrepreneurship and Innovation Management in response to COVID-19 pandemic. He has also delivered a keynote address on the topic Detection of Medical Disease, Lung Cancer using Image Processing Tool on 18 June 2020 in international conference organized by the Ministry of Public Education, Uzbekistan. He has been appointed as a mentor for change by NITY-IO, Government of India for development of skill set lab at New English School, Landewadi. He is acting as a president of Indian region for the chapter of CBEES, Hong Kong, China for their technical and scientific international activities. He is also acting as an editor in charge for the international journal IJRPET. Now, I would request Dr. Manoj Tarambli sir to say a few words.
Hello, I, Dr. Manoj Tarambale, in charge principal, Pune Vidyarthi Gruhas College of Engineering and Technology and GK Pate Institute of Management, welcome you for this one-day national event, Virtual Labs Outreach Workshop, which we are organizing for the faculty of Polytechnic and the students of Polytechnic. This workshop we are organizing in association with IIT Bombay. I sincerely thank Dr. Pushpadeep, Project Manager, and Dr. Santosh, Principal Investigator, Virtual Lab IIT Bombay, for their kind support and keeping faith on us and allotting this workshop to conduct. For their wholehearted support, I am thankful to them. I also thank my management, Pune Vidyarthi Gruha, for allowing for such type of program which are completely academic based for the benefit of the society at large. This organization is possible with various regional centers and nodal centers of virtual lab from Baroda, Mumbai, Pune, Navi Mumbai and Aurangabad. So I am thankful to them also for making this event grand success. Thank you. Virtual Lab is an initiative of the Ministry of Education. Virtual Lab includes web resources, video lectures, animated demonstrations and so on, and hence one can say that it is a complete learning management system. Virtual labs for various disciplines of engineering and technology are available, such as electrical, electronics, communication, computer, mechanical, biotechnology, chemistry, physics. Now these labs in virtual environment will give students to feel as if they are doing a real-time experimentation, and hence it will carry an importance. Virtual lab is one of the excellent ICT tool student and faculty can use, as these labs are available 24/7. Anyone can access from any place, and these are available absolutely at free of charge. Faculty can use these labs for giving live demonstration of the virtual experimentation, so that they can bridge the gap between their classroom teaching and the physical lab conduction. Virtual labs is one of the best practices followed by Pune Vidyarthi Gruha's College of Engineering since 2015. Under the guidance of IIT Bombay and the faculties and students of Engineering College successfully developed more than 100 experiments to cater the need of university syllabus. After rigorous review, these experiments are available and published on the virtual lab portal of IIT Bombay. During this COVID-19 pandemic situation, virtual lab experiments developed proved to be the best for conduction of experiment in online mode. These advantages to the students and faculty to demonstrate the actual working of the experiment but in virtual mode. पुणे विद्यार्थी गृहास College of Engineering is a major regional center and is instrumental in introducing virtual labs experiment in engineering syllabus. At present, under the umbrella of this regional center, 57 plus nodal centers are working effectively. Virtual Lab is a recently developed distance learning tool that is giving solution to boost the quality of engineering education, strengthening the understanding and providing the necessary practical skills to the student and faculty. I hope faculties of Polytechnic colleges will use this tool for effective implementation of teaching learning process for the benefit of the student to demonstrate the experiment in virtual mode for better understanding. At the last, I hope this one-day workshop at the end will be helpful to the faculties of the Polytechnic to take this experimentation new mode ahead and use it in the teaching learning process effectively. Thank you.
Hello guys and welcome. My name is Ishan Nirkar. I'm a student of SE Computer at PVG's College of Engineering and Technology. I have also been a member of the VLabs community for approximately the past 7 months and have successfully completed the audit course. I'm a certified HTML developer from IIT Bombay. I have also participated in 2 hackathons in my first year. And I was also one of the resource persons for a web development workshop held by PVG's College of Engineering and Technology. Now, I would like to introduce Professor Surendra Krishnath Giram, who is the principal of AISSMS Polytechnic, Pune. He completed ME Mech, ME Prod, and is currently pursuing a PhD Mech. He has an experience of 29 years in teaching and 1 year in industry. He has also published books and papers, like the first one here being published with ISBN 97833200066, and the year of publication was 2019. And the second one being Energy Conservation and Audit National Conference, Elecom 98, Pune. He also has 2 professional memberships. First one being Life Membership of ISTE LM 16314, and the second one being Chairman ISTE Faculty Chapter. Now, having said that, I would like Surendra Krishnath sir to say a few words.
First of all, I take the opportunity to thank IIT Mumbai and Ministry of HRD, Central Government of India, for identifying our Polytechnic as a nodal center for virtual labs. As all of we know, the key advantages of virtual laboratories are access anytime and anywhere, and one can repeat experiments as many times as needed to fully understand the material. Virtual labs allow students to participate in lab-based learning exercises without the costs and limitations of a physical lab. With the help of virtual labs, teachers and students can use advanced technology that yield authentic results. I appeal all the teachers and students of polytechnics to access the virtual labs as far as possible. As we are aware, in the pandemic situation of COVID-19, most of the engineering colleges, teachers and students have taken the benefit of VLabs to develop their motor skills. As a nodal center of VLab for polytechnics, we have tried to map the present students of various disciplines with respect to polytechnic curriculum. But it has been observed that most of the contents are applicable to engineering college students. So I request the concerned IIT people to develop separate virtual labs for the polytechnics. In this context, we are, as a nodal center and accredited polytechnic, are ready to fulfill all the requirements to develop VLabs for polytechnics. Also, I would like to appeal to all polytechnic faculties to use VLabs as far as possible, and one can use the same in following way: as a visual aid to teach complex concepts, to refresh students' knowledge before teaching new material, as a pre-lab exercise, to provide lab work to courses with no existing lab component, to facilitate online learning, as a post-lab exercise, as a content beyond syllabus. It's my humble request for all polytechnic teachers and students to please support the efforts of IIT Powai and Ministry of HRD, Central Government of India, by utilizing the virtual laboratories as far as possible. Also, as a nodal center of VLabs for polytechnics, we are ready to conduct outreach workshops for polytechnic teachers and students. And we feel such kind of workshops are most significant to increase awareness among all concerned end users. Lastly, but not the least, on behalf of AISSMS Polytechnic Pune, I'm thankful to all of you for patient listening, and I take the opportunity to thank IIT Powai and Ministry of HRD Government of India for identifying us as a nodal center for of V Labs for Polytechnics. Thank you, one and all.
Greetings everyone, Rajesh Nilesh Thakre here. Let me introduce myself first. I'm a second year IT branch student at Pune Vidyarthi Griha, Pune. I recently completed the VLab audit course and I'm a mentor and trainee at VLab PVG COET. I also was a mentor for the National Web Development event held on 17 July 2021 in coordination with VLab. Along that, I'm also a member of other technical clubs like ITSA, EDC and Robotics. I have been certified in HTML and CSS course from IIT Bombay. Allow me to introduce you all to an extraordinary person, Honorable Nitin Bhate sir. He has always been inquisitive to acquire knowledge and develop new skills and has reached new heights with his inspiring leadership qualities and communication skills. He completed his BE in Chemical Engineering in July 1994 from PVPIT, Gurgaon. Then he got his master's degree in Polymer Technology stream in July 1998. Then he acquired his PhD from IIT Bombay in 2008. He started his rousing professional venture as a lecturer in Department of Chemical Engineering in MSU, Baroda in 1998. He is currently doing a wonderful job as head of the Technology and Engineering Department at MSU, Baroda. He has co-authored 2 books relevant to Chemical Engineering Laboratory and several publications in the Journal of National and International Repute, along with many other representation in renowned conferences. He has coordinated and conducted various workshops for curriculum development up to this date with VLabs and MSU Baroda. He is academic committee member of National Children's Science Congress, Baroda district. He also is nodal coordinator for virtual labs at MS University of Baroda and regional coordinator of virtual labs for Gujarat region. Due to his hard work, he has received many honors. He won the Best Presentation Award in joint Indo-US ChemCon 2005 conference in December 2004. He was awarded with Dr. R.P. Parnikar Purnavad Award for Excellence in Engineering and Technology in 2017. He was felicitated by Rajmata Shrimati Shubhangi Gaikwad for successful execution of social science project competition and contribution. He has also received letter of recognition from Tata Center for Technology and Design, IIT Bombay, to name a few. He hasn't stopped there. He introduced the concept of classroom library and donated about 16 such libraries in municipal schools in year 2014-15. He amazed us with gameplay, which demystifies chemistry and makes it interesting for school children in association with Tata Center for Technology and Design at IIT Bombay. I now appeal Bhate sir to take over.
Well, various faculty members would have, talked about or introduced the concept of virtual labs and even showcased several, labs associated with different domains. What I'm going to do today is a little different from what they have done. You will agree that whichever experiments were showcased, right, somebody has to develop these experiments, isn't it? So now there is a certain way or there is a certain protocol which has to be followed to develop a virtual lab. And this is precisely what I'm going to emphasize on in my today's talk. Now, like you have been introduced to the existing virtual labs. Now, just to give you a brief history about virtual labs, this exercise started almost a couple of years back with several institutes contributing towards the development. Unfortunately, there was no unified procedure which was suggested or stipulated, and hence different institutes and different individuals use different platforms to create virtual labs, and this resulted into a lot of non-uniformity as far as the development procedure is concerned and the methodology is concerned. Majority of these labs are based on licensed or proprietary softwares, and hence it becomes very difficult to bring about any a change in the given experiment. So when I say change, it essentially means that suppose if I feel that a given experiment needs to be modified or it could be updated, there are certain things which can be incorporated. Of course, by making help of a person who is good at coding and who can comprehend the code. But unfortunately, in the present class of virtual labs, the existing virtual labs, this is extremely difficult because these codes are not available. Because in order for these codes to be available, there are copyright issues associated with them, right? The fact that it was, as I mentioned, that there was absolutely no proper protocol which was proposed, and hence the learning objectives have not been clearly defined, right? And even the cognitive levels, which we talk about in various programs, including NEP, do not become a part of these virtual labs. By saying this, I don't intend to criticize the existing virtual lab. See, it was absolutely essential for somebody to get started and initiate this exercise, and that is what people did. So that's fine. The other aspect is that all the domains have not been addressed. By domains, I mean that there are very few experiments or virtual labs which have been developed for certain disciplines. In fact, in some disciplines, you won't find a virtual lab at all, right? So there is enough scope for virtual lab development. This is what I was coming to, and this is what I wanted to emphasize on, and hence the idea of defining a proper pedagogy, right? Now, what is the necessity of pedagogy? Well, the present labs, that is the ones which are now going to be proposed or which have been proposed in the last 1 or 2 years, are all based on the FOSS-based platform. What is a FOSS-based platform? This is free and based on free and open source software, right? And the whole idea of implementing this or suggesting this platform is that at any point of time, even if you want to make any kind of changes, right, this code is available because there is no copyright issue associated with sharing these codes. So with this so-called new suggestion and the protocol associated with the development, it becomes much easier and flexible to modify a given lab or even bring about changes in the existing lab, right? Or if you are proposing a new lab in the future, if somebody wants to bring about any changes, it is possible and it is much easy to do this exercise. Well, this also sets a path for a standard protocol for the new virtual labs, irrespective of the discipline. I'm not talking about the content, but I'm talking about the procedure which is followed for developing a new virtual lab, right? In any development of any virtual lab, what is important is the clarity of thoughts, because until unless the person himself or herself is clear, okay, you really cannot convert it into a virtual platform, right? So there are transitions which actually happen. So the thoughts are translated into actions, and these actions are ultimately appear on a virtual platform. I already talked about the ease in the upgrading and the revamping of an existing virtual lab. The added advantage of having a pedagogy in place is that the learning objectives and the cognitive levels can be well defined for a given lab, and you can actually integrate integrate these two so that it becomes more meaningful, right? I'll explain this with an example as we go ahead. When I talk about pedagogy, what is important is the components associated with the pedagogy. In fact, there are four components, I would say key components associated with pedagogy: the learning objectives, the purpose, cognitive level, and the learning outcomes. However, any pedagogy, okay, will be incomplete without three secondary, or I would put it as primary, components. That is the information pertaining to the given lab, the focus area, and the instructional strategy. Right now, rather than just putting it as a sketch and just trying to explain what each one of this means, I believe that it would be much simpler for you to digest if I put it in the form of an example, right? So let me take a very simple example of a laboratory microscope. Let's say that we want to develop a virtual lab experiment for a microscope. So what do you need in case of information? The general information about microscope, why it is used, where it is used, what are its applications, what are the pros and cons, etc. Okay, general information which a layman needs to know. Then comes the focus area. So focus area would be, in fact, there are certain stipulated focus areas which one has to know. Okay, so this is so there are 6 focus areas. So reinforce theoretical concepts. Okay, and which essentially means that you need to understand the topics after seeing it visually, which is possible in virtual labs. Instrumentation and practical skills, so instrument specific skills. So meaning this focus area sort of works best for the lab under discussion of the microscope. Then you have experimentation, which talks about the trial and error methods and the traditional experiments which are conducted in the lab. Then we have the data analysis where you have to analyze graphs, results. Okay, there is data error analysis. Then we have modeling, where different models and theories are tested and the lab is oriented in that fashion. Learn from failure is essentially an instrument failure, hazardous working environment. See, there are certain experiments which we know that they are very important, but they cannot be conducted in the lab from the safety aspects. However, in case of virtual lab, all these things really don't matter because you're doing it on a virtual platform. Even if something explodes, okay, it is going to explode on a virtual platform, so there won't be any problem, right? So we are talking about these. Let me now talk about the learning objectives. What will be the learning objectives of for a microscope? The objective would be to understand the principle and the working of the microscope, right? What would be the purpose? The purpose is that a user, it could be a student or whomsoever, should be able to make use of the microscope for a given for a given application, right? There are certain cognitive levels which are required in the formation of the virtual lab, which I'll talk about a little later. Coming to the learning outcomes, what would be the learning outcomes? The learning outcomes would be the user is able to use the microscope, he or she has understood the principle and the working, right? And any kind of samples which are there can actually be tested using the microscope. So these are going to be the learning outcomes, right? So now let me first talk about the instructional strategy, because in building of a virtual lab, this is something which is equally important. So there are 4 types of instructional strategies: expository, guided inquiry, problem-based, and project-based. Okay, expository is with the traditional physical lab, and the present experiment under discussion also falls in this category. Guided inquiry is inquiry-based learning, a primary level of open-endedness. Problem-based is experiment can be posed as a problem statement, and learning objectives are usually defined. And project-based is a real-world problem. It is in true sense a open-ended problem, right? So these are the various ways in which you can develop labs, right? Coming to the cognitive levels, there are in fact 6 cognitive levels, starting from the most preliminary one, which is the remember, and going up to create. Now it is not mandatory to always go to the create level, right? It all depends and varies from experiment to experiment. It is also desired to go to this level, but believe me that all experiments cannot be taken to this level. Okay, so there are certain limitations, and be it, because if it is a simple demo experiment, okay, we need to restrict it only to remember and understand, because that is what is the requirement, right? What is closely associated with cognitive levels, are the learning objectives, and learning objectives need to be defined or need to be mapped based on the cognitive levels, right? So you will see that there are several keywords which we call action verbs, which are associated with the learning objectives. So what it means is that once you fix the cognitive level, right, you need to use these action words pertaining to the given cognitive level in your learning objectives. So it could be in case of microscope, just to give you an example, one of the exercise or the activity could be label the parts of the microscope, because unless a user knows what are the various parts of the microscope, it would be difficult for person to actually go ahead and experiment with it, right? Pedagogy becomes in fact one of the inputs, okay, to the simulator, directly or indirectly. So what happens is that pedagogy puts forth a path, okay, which needs to be followed. This gets translated into tasks and flow, okay, for I'm talking the simulator language. That is any kind of changes or the patterns which prevail in the simulator are ultimately associated with the task and flow. Let me give again another example about Tom and Jerry. Okay, so there is a certain pedagogy which has been maintained, that what is the path which Tom and Jerry are going to traverse. Now, for a person who is into coding to do this exercise and build a simulator, what is required is he or she needs to understand what are going to be the tasks and what is going to be the flow in which these series of events are going to take place. And now this becomes sort of a theoretical information. It needs to be translated in a pictorial format, which is done using the storyboard, and this put together forms a simulator. Now, apart from Tom and Jerry, where there is no assessment as such, but in virtual labs you also need to have an assessment segment, and this is very much possible in virtual labs, and this also has to be aligned with the task and flow. So all of these put together build a simulator environment which ultimately takes shape of a virtual experiment, right? So this is in nutshell what I wanted to discuss about the pedagogy associated with the development of virtual labs, right? So I would like to end by saying that a good pedagogy certainly simplifies the virtual labs development to a much greater extent. There's a lot of clarity involved, and you'll end up getting a quality virtual lab. What you need to invest in virtual labs development is knowledge, creativity. You need to put in effort. Synergy is required because you also need to align with other domain experts, and you need a lot of patience, right? Which is one of the inherent aspects involved even in research and teaching learning process, right? So I would end my session by saying that let us all contribute towards the virtual labs development and its outreach. Thank you very much.
Greetings to all. I am Mrs. Kshama Balgude, working as an assistant professor in PVG COET and JKPIM Pune. I am a virtual lab coordinator for Information Technology Department. I am going to demonstrate virtual lab for computer network. This is the name of the virtual lab, Fundamental of Computer Network. And from this network, I am going to demonstrate two experiment, IPv4 addressing and configuration of cables. The links for both the experiments are given here, and this lab is developed by Maharashtra Institute of Technology, Aurangabad. This lab is mapped with MSBTE syllabus for the subject Data Communication and Computer Network for Computer Engineering, in, Computer Network for Information Technology, and Advanced Computer Network for both the discipline Computer Engineering and Information Technology. So now I am going to demonstrate the experiments. So using this link vlabs.iitb.ac.in, you can open this portal where all the labs are available. Just click on the Explore Lab, and from this select the option Approved Lab. So under this tab, many virtual labs is present. From here you have to be click on a computer network. Then this page will be open. So this is actual virtual lab, Fundamental of Computer Network. Here you have to be click on the Explore. And here the experiment is present, IPv4 addressing. So click on this. You can see there are many tabs are available at left side corner of this page. The aim means the aim of the experiment. Theory related to this experiment as well as related to this particular topic is present here. Please ask the student go through about this particular topic and experiment. The pre-test is also there. Student can give the pre-test. Procedure of experiment is also given here. The simulation of experiment is given here, and post-test is also given here. So please ask the student go through all the tab given here to get the more knowledge about this particular topic. So now I am going to start simulation. For simulation, you have to be click on this link. Click here for simulation. Then the simulation will be open. So this is actual simulation for this experiment. In this experiment, you have to check all the machines are in a network or not. Here, three classes of IP address are given. Class C, B, A. You have to be select any one. Suppose I am going to select C, then submit it. So one network ID is generated. You have to use this network ID to give the IP addresses to the machines. So every time there will be new network ID. Also you have to give the subnet mask. Here also. Here also. Now you have to check all these machines are in network or not. So all these machines are in network. You can change the value of anyone. Suppose I am going to change the IPv4 address of PC number 2. 30 I have written here. Then you can see the result is PC2 not in a network. Similarly, you can change the subnet masks of any machines and you can check again the result. Here PC3 not in a network. So I'm again going to make the corrections here and evaluate. So now all the machines are in network. Similarly, you can do for the class B. I am going to click on class B, click on submit, and you can find the new network ID is generated in class B. So use this network ID. So similarly, change the subnet mask. And now evaluate. So all are in network. Now change any one value here to get the results and evaluate it. So you can find now PC3 not in a network. So similarly you can do for the class A. When you select the class A and when you click on submit, the new network ID is generated. You have to use this network ID to give the addresses, IP addresses to the machine, as well as accordingly you have to change the subnet marks and check the result. So this is experiment number 1. The experiment number 2, from this particular web page, you have to be select the lab under construction. So when you click on this page will be open. Here many virtual labs are given. You have to be select the virtual lab for network, the computer network lab. When you click on this tab, this page will be open. You have to click on explore. When you click here, then this page will be open. Here 4 experiments are given. I am going to demonstrate only one experiment, configuration of cable. You have to click on this configuration on cable. Then this window will be open. Here also same tabs are given. The aim of experiment, theory related to that particular topic. So please ask the student, just go through the theory to get the more knowledge about that topic. Then pre-test is also there, procedure of experiment is also given, simulation is also given, and post-test. So for simulation, click on this link, click here. So when you click, this page will be open. Here you have to be select the devices which is used for this particular experiment, RJ45 connector, crimping tool, LAN tester, and cable. If I select the switch, so this is a wrong device which is not used for this particular experiment. Then go to next. Then here you have to select the cable. The 3 type of cable are given, straight, cross, and roll over. I am just going to select the straight. Now you have to select the color code. So first is orange white. Same will be here orange white because this is a straight cable. Then orange, select it here orange. Then next is green white. Then select it the green white. Then next is blue, select here blue. Next blue white, select here blue white. Next is green, here also green. After that brown white, here also brown white, and the last one is the brown. So now I have select the color code for both switch port and PC. Now you have to check whether your selection is correct or not. So for that you need to click here on this red button, and you can find here the bubbles color gets changed from pink to green. Green means what combination you have selected, what color code you have selected are correct. Now did you made right cable? Yes, because all the bubbles turn into green in color. So just click on OK. So cable is right. So similarly you can do it for the cross as well as the roll over. So this is a second experiment, configuration of cable. In the same way you can execute other experiments given here to get the more knowledge regarding that particular subject. What the topic you taught during the lecture, that also you can demonstrate using VLab, and also this VLab is very much useful for practicals. Thank you all. Thank you for listening me.
Hello everyone, my name is Tanvi Tarkunde and I am a mentor at VLabs Digitizers. A short intro about myself. I have successfully completed audit course for virtual labs. I have been the member of Virtual Labs Digitizer Forum since 2020. I have been certified by IIT Bombay for HTML Advanced CPP and Python 3.4.3. Now I would like to introduce Professor Geeta Narayanan ma'am. She has been the Associate Professor at Biomedical Department at Vidyalankar Institute of Technology. She has completed BTech in Electrical Engineering from Government Engineering College, Thrissur, Kerala in 1991. She has also completed MTech in Power Electronics from NIT Calicut in 1994. She has an experience of 28 years in Mumbai University. She has been the HOD of the department for around 8 years. Her subjects of interest are digital design, very large-scale integrated circuits, control systems, robotics, embedded systems, and IoT. Her papers have been published around 20 publications, out of which 7 to 8 are in IEEE. Now I would request Geeta ma'am to say a few words.
Hello everyone, I am Professor Geeta Narayanan from Vidyalankar Institute of Technology, Mumbai. I am the Nodal Coordinator for Virtual Labs at Vidyalankar. Today I am going to explain and demonstrate a lab, Programmable Logic Controller Lab, and I am going to concentrate on experiment implementation of logic gates. This lab is coming under discipline Electrical Engineering. Before going into the lab, let me thank Virtual Labs IIT Bombay and PVG College of Engineering Pune for giving me an opportunity to explain and demonstrate Programmable Logic Controller Lab in this workshop. Programmable Logic Controller Lab is developed by COEP Pune and it is available at this particular website. Programmable Logic Controller Lab is mapped to the subject Industrial Automation in MSBT. The course code is 22534 and it is coming under 5th semester. This subject is elective for Electrical, Electronics and Telecommunication branches, whereas it is compulsory subject for Instrumentation Systems and Instrumentation Control. Let us go into this particular Programmable Logic Controller Lab on Virtual Lab website. So, to go to this particular lab, you have to go to Google and type Virtual Lab IIT Bombay. This is the site Virtual Lab IIT Bombay. You have to click on this. Then Virtual Lab IIT Bombay site will open. Here, if you click on labs, it will show the different disciplines. In discipline Electrical Engineering, if you click, you can see all the labs which are associated with Electrical Engineering discipline. If you scroll down, you can see the PLC lab. PLC is the Programmable Logic Controller Lab. So when you click on Programmable Logic Controller Lab, this page will open. This is giving a small introduction to the lab. In this lab, we will demonstrate ladder programming. We will implement logic gates, DOL starter, online on delay timer, off delay timer, up and down counter and many more. Now let us go into the list of experiments. If you open the list of experiments, there are 8 experiments in this particular lab. So first experiment is a study hardware and software used in PLC. Second experiment is the the experiment which we are going to consider, that is implementation of logic gates, and I will go through other experiments also. There are experiments, implementation of DOL starter, implementation of on delay timer, implementation of off delay timer, up down counter, arithmetic of instructions, PID controller, etc. Let us go to the experiment implementation of logic gates and click on that. If you click on this implementation of logic gates experiment, this page is opening. Here, if you see on this page, on left side there are many tabs which are given, which can be clicked to see the aim of the experiment, pre-test, theory, simulator, procedure, audio video, etc. So if you click, these are similar to the lab manual we give to our students during the practical. So they can virtually see the lab manual. So if you click on aim, it is giving the aim and objective of the experiment. Then there is a pre-test given. In the pre-test, there are 5 questions given. So we can test the level of the students before doing the experiment by looking at the score they are getting in the pre-test. I am randomly clicking the values, the inputs, the answers, and then I am submitting it. When I submit, I will be getting my score. I can view the solution. I am not getting full score, so I can take the quiz again, or I can also view the solution. So in view the solution, I am getting this output, and I can take the quiz again, so it will be taking you to the same quiz again. Next tab is theory. In the theory tab, extensively the theory is explained about the experiment. So there are 2 parts of theory. One is the logic operation, the digital electronics required, and the other part is about the theory about the PLC ladder programming. So in the digital electronics part, they have explained about the logic and then development of logic, then truth tables, and then Boolean laws and Boolean basic laws are explained. And in the PLC, they have given all the instructions, relay logic instructions, and how we are doing the ladder programming, this type of ladder, one rung of the ladder, and they have given all the relay instructions, normally open contact, normally close contact, output, coil, output negated, latch, unlatch, all these instructions are given in the theory. In the next tab is simulator. I am just opening the simulator in a new window so that I can see this procedure and the tab together. Before going into the simulator, I will go to the procedure. In the procedure, all the important steps for doing that experiment is explained very nicely. So the pre-experiment, you have to prepare the ladder diagram for all these logic operations on a paper, and then we have to start with the experiment. And when we start the experiment, it is showing the opening window. If you go to the simulator and see the opening window, you can see the opening window is like this, and that is screenshot is shown here. Then what is the next step? You have to add a rung, so that is given. Then how to add a component is given. Then how to give the input, the name to the component is given, and how to test the output is given, and how to create another ladder is given. So all these things are given in a very step-by-step manner, very nicely explain the procedure. Now next tab is audio video. Audio video in this particular case is not provided. Next is post-test. So after doing the experiment, what the students understood can be found out by doing this particular post-test, and looking at the score of the post-test, we can make out what is the level of understanding of our students. After that, they have also given some review questions which the students can search and find out in textbooks or in on websites. They can search and find out answers for these questions. They have also given the different references used for this experiment, and there is a feedback form also. So let us go to the procedure and try to do the experiment implementation of logic gates. I will explain the implementation of AND gate and OR gate on the simulator. So the first step is, according to the procedure, is to add a rung. So in this, when you open the window, you can see there are different inputs here. This is an add rung. There is normally open contact, normally closed contact, then output. And these are the components required for realizing a logic function. On right side, we are having open, save, compile, run, development. So run and development are two different environments. In run mode, it will not allow you to develop, and in develop, there is no running. So we have to take a new rung. I added a rung. Now I have to give input AND gate. For AND gate, two inputs are connected in series. So I am considering normally open contact, and I am giving two inputs like this in series, and one output I am connecting. If I am connecting here, it will show that it cannot be placed in the middle. You have to place it at the end only. So it is giving the error messages also. So I have made the rung for that. Now I have to give the input, the name to these inputs. I have to tag it as, we can call it as A. Right click, tag B, and here again right click, tag out1. So my ladder diagram for AND gate is ready. After completing the ladder diagram, I have to compile the ladder diagram. So it is giving me compiled successfully. So I press OK. Now I can run. I am running the code. So when I am running the code, there is a green line coming here. That means the ladder rung is energized. It is already energized. So I have to just give the input. How to give the input? This is open, so 0. B is open, so 0. So what I have to give? I have to toggle it and make it as 1. So now A is 1. I am toggling and making B also 1. So when both A and B are 1, my output is also high. So my AND gate is implemented. Now if I want to add one more gate to this particular ladder diagram, I can click on development. So that green line has gone. I can add a rung, and let us consider we have to add an OR gate, or we can even create any Boolean logic expression also. So if you want to add an OR gate, we need to connect these switches in parallel. So for that I have to add a parallel block here. So for plus, if I click, then the parallel block has come. I am going to give the same input A and B on the parallel line, and output is connected here. And now I am going to tag it also with the same name, so that you will come to know that they are linked together. If you are giving the same name, they will be linked together. So that is what we are doing. And here also I am tagging it and making it as out2 and submit. So my ladder diagram is ready for AND gate and OR gate also. Now I am going to compile. So compiled successfully. Now I have to run. When I run, both the rungs are energized. Now you can see that since the same tag is given, if I toggle this switch A, this is also toggled. And it is an OR gate, so either A or B is a 1, the output will be 1. An AND gate will be on only when both A and B are 1, so that is also working. Now here you can give beyond this, you can give any other logic expression also to realize, and the students will be developing the logic, and then they will be realizing using this particular ladder diagram. So those things can be done in this particular experiment. Now let us see one more experiment. If I go to the same list of experiments, I can see there are DOL starter is there, and then delay timer is also there. Let us just see how the delay timer is utilized. So if your theory I am just skipping, and then I am going to the simulator. theory they have given about the different timers. There is a on delay timer, off delay timer. Here, this is an on delay timer. That means it will be on for some time, for the specified time. After that, the delay will be that after that delay, the contact will be switched on. So it is on delay timer. There are three. There is a T on, there is an enable, and there is a DN also. DN means done. Timer timing is the TT. So if you go to the simulator, we can see that basic, that is adding rung and all, and counter is also available. So in basic we can add a rung, and in the counter timer, if you go, this T on can be placed here. So the T on has come. So in the T on there are done, timer timing and enable. So I have to give an enable, and then I can see the output which is coming. Okay, so for knowing this DN and TT, I need two more contacts and two more outputs. First of all, let us configure this. For configuration, I have to give a name T1. I am giving T1, timer 1, and I have to give a preset time also. So I am just giving 1000 milliseconds as the time. So the timer delay, the contact will be closed after 1000 seconds. So I am just adding rung, and then I am testing it. For that, first I need one for enabling and another one for the done, timer done, and another rung can be used for timer counting, TT. So I can tag, so there can be some output also, so that we can see whether that is working or not. So I am just connecting some outputs also. Now I am going to mouse. So this will be the enable. So I will just give enable. I am just give enable. It is an enabling for the timer. And these are, one is T1 DN and this is T1 TT. So I have to give tag T1 underscore DN and T1 underscore TT. So I have given the names. Now here I am giving tag as out1 and out2. So what will happen? Till the time reaches 1000, your T1 TT will be on and out2 will be on. And when the time reaches 1000, the T1 DN will be on and this out1 will be on. So that is the effect we can see. So I am just compiling this circuit, compiled successfully. Now I am running this. So when I am running this, you can see if I enable this. So till it reaches 1000, this was on. So I am just disabling this. Disabling this, and when I am enabling, till it reaches 1000, this was on, and once it is reached 1000, that is done. The timer done will be on. Hope you have understood the programmable logic controller lab, and beyond the experiments list which are given in the list of the experiments, we can also give any ladder diagram development type of problem statement to the students, and students can explore on the development of ladder diagram by using this programmable logic controller lab. It is giving an environment in which the students can develop ladder diagram. Hope you have understood my explanation. Thank you for listening. Thank you.
A very warm welcome to everyone. I am Shubham Kothari, head at the VLabs Digitizers Forum at PVG COET and GKPIM. I would like to give a brief introduction about myself. I have been a member of the Students Club at PVG COET and GKPIM since 2019. I am the head at the VLabs Digitizers Forum. I am also a mentor as well as a student trainer for the VLabs Digitizers. I have been a senior trainer for the Bootathon Knockdown the Lockdown 1 and 2 organized by IIT Bombay. I, along with my team, have been awarded the Platinum Developer Certificate in the first ever Bootathon organized by Virtual Labs for the digital logic design using Logic Gates Virtual Lab. I have also developed the Integrated Circuits Analysis Virtual Lab. Along with all this, I have also been certified by the Spoken Tutorial IIT Bombay for courses like HTML, CSS, C, C++, Python and Arduino to name. It gives me immense pleasure to introduce to you all Dr. Abhilasha Mishra, who is Associate Professor and Head at the Department of Electronics and Telecommunication Engineering at Maharashtra Institute of Technology, Aurangabad. After completing BE from MIT Gondia, ma'am pursued her higher education ME from Government College of Engineering, Aurangabad in 2000. Later, ma'am completed her PhD in antenna designing from Kavitri Bahinabai Chaudhary, North Maharashtra University, Jalgaon in 2013. She is a regional coordinator for the Marathwada region. Ma'am has published 55 research papers on various topics like antenna technology, image processing, remote sensing, and optical fiber communication. She has also published 2 patents in the Indian Patent Public. Ma'am is a recipient of the Best Paper Award in the 3 IEEE conferences ICMO 2017, IEEE IAW 2013, IEEE INC EMIC 2018. She has received the prestigious IET Professor S.N. Mitra Memorial Award in 2013 for her outstanding contribution and leadership role in radio broadcast science and technology during the last 10 years. Ma'am has also developed the first virtual lab of the Marathwada region, which is hosted by the IIT Bombay portal. Ma'am has organized IEEE conferences of world repute, that is the IEEE Indian Antenna Week 2013 and IEEE Applied Electromagnetics Conference in 2017. The resource persons were from Massachusetts Institute of Technology, NASA, San Diego University, IITs and NITs.
Hello everyone, I am Dr. Abhilasha Mishra, Regional Coordinator Marathwada Region Virtual Labs IIT Bombay. I welcome you all on this Virtual Labs Outreach Workshop. Today I am here to discuss with you about the roles and responsibilities of Nodal Center. The main objectives of the Virtual Lab project is to provide the remote access to the labs in various disciplines of humanities, science and engineering. It aims to cater at the UG level, PG level as well as to the research scholars. So the labs of various domains are available to the students. It also enables to the students to learn at their own pace and to arouse their curiosity 24/7. It's a complete learning management system that includes web resources, animated demonstrations, and self-evaluation. In a nutshell, if we look towards the virtual lab, so what are the value added in a nutshell? So let's have a look on it. It's a complete integrated learning management system. So content is available at one place. It includes animation and video tutorials to give the better insight to the students. It allows the students to make the mistakes, so they are learning from the experiments. Self-evaluation quizzes are available. So before the performance of the experiment, student will learn how much knowledge he has, and after performing the practical through virtual lab, he can test his knowledge with the help of post-lab quiz. So it's a self-evaluation system. It makes students more confident about the learning system. It's an on-demand lab which is available at 24/7 and students can learn at their own pace. There are various regional centers under IIT Bombay like PVG, Pune, Gujarat University, MIT Aurangabad, DY Patil Mumbai and MSU Baroda, etc. Let's have a look on key benefits to the institute through virtual lab mission. If you are getting associated with the virtual lab, so you are contributing in a national mission of ICT education and you are collaborating with MHRD's project. Once you are getting associated, definitely you will be contributing in virtual lab development and the usages, that is performance by the students in virtual labs. So once you start these activities, so you will get credit for your institute in NBA and NAC evaluation. Once you work in content development, so this is the technical development for whole community. Students can also use and faculties can also use. Internship opportunities are available to the students of your institute with IIT Bombay and associated regional centers. And once you contribute, you will get the nationwide visibility of your own institute. Role of Virtual Lab Nodal Center. As we belong to Maharashtra region, we are associated with IIT Bombay. So Virtual Lab IIT Bombay is an apex body under which the regional centers and nodal centers come. So after IIT Bombay, it comes the regional center. The regional center is taken care by regional coordinator and regional technical coordinator. The nodal center care has been taken by nodal coordinator and nodal technical coordinator. So under regional center, there are various nodal centers available in the region. Under the nodal center, as it is the main center at the institute level, various departments come and department has to nominate one coordinator from each respective department. The course coordinator of the department will work on the syllabus content and try to identify the syllabus available in virtual labs. So by mapping the syllabus, he can work on the performance of the virtual lab with the students. Either if labs are not available, he can think of developing the labs. And once the syllabus is mapped, the student will perform the virtual lab in coordination with the course coordinator. And after performance, the student will submit the online feedback. This is how the virtual lab system works on. So stakeholders and their role. The nodal coordinator has been nominated by the director or head of the institution. The nodal technical coordinator supports technically to perform the virtual labs in the center. He also aims to develop the content with the help of students and faculties of the institute. Departmental coordinator is coordinating the virtual lab activities of the respective course with the help of the course coordinators. And course coordinator will train the students to perform the virtual lab, and also student will get training to develop the contents. And this is how everyone is participating in the virtual lab development and virtual lab performance. If you wish to have the nodal center, so the nodal center setup requirements or eligibility for this is you don't have to pay anything for having the virtual lab at your institute. So no financial liability. Free access of the lab is available to everyone. And the institute cannot charge the students for the virtual labs. So everything is available freely to all the students. Procedure to establish a nodal center. So if you wish to go for the Nodal Center, you have to conduct one outreach workshop by Regional Center. Regional Center will provide the feedback to IIT Bombay. The credentials for the expression of interest will be issued to head of the institution, where he will select the Nodal Center coordinator and the Nodal Center technical coordinator. So selection of Nodal Center under Regional Center will be accepted by the IIT Bombay, and commencement of the Nodal Center activity will carry on by the Nodal coordinator, and institute's group of department coordinators will support this activity and provide the training on virtual labs, that is also called as in-house workshop, to the faculties and students at regular intervals. So the responsibility of Nodal Center plays a very important role in having the maximum usages and the content development. So the Nodal Coordinator is the main interface between the outreach team of Virtual Labs, IIT Bombay and the Nodal Center in association with Regional Center. The execution of training sessions for the students and faculty members of the institute can be conducted by the Nodal Coordinator. The training session can be conducted for the staff members and the students. So he has to popularize the virtual labs among the students, and the field testing of the labs can be supported at the institute level, and the feedback can be submitted to the center. So support in testing and debugging virtual labs while using them. A monthly progress report has to be submitted by the Nodal Coordinator. So this is called as the virtual labs usage. How much lab has been used by the particular student. So complete calculation of these usages has to be submitted as a monthly progress report to the IIT Bombay through the portal, which has to be signed duly by the director or head of the institution. The Virtual Lab Nodal Center has to conduct one workshop per semester as an outreach activity of the virtual lab. The faculty members and students from nearby places and institutions will participate in this workshop. So, virtual lab will get wide coverage to all the levels of the institutes. The targeted attendees in each workshop can be approximately 100, and it can exceed as well. The list of participants should be shared with IIT Bombay, and the images of the workshop can be shared. So nodal centers will coordinate workshop, and if required, the outreach team from IIT Bombay may contribute. The usage target more than 8,000 per year has to be there, and it can be covered from January to December. So at the end of the year, we can target the usages of 8,000 approximately. So intimation of workshop dates and other training session has to be reported to IIT Bombay, and the workshop conduction report has to be submitted by including the relevant photographs, and the template is shared by the IIT Bombay. So these are some of the labs developed by Team MIT. So this is how you can get the worldwide visibility about the developed labs for your institute. This is the Computer Networks Lab developed by the Team MIT. So Maharashtra Institute of Technology is getting wide coverage of visibility to all the virtual lab stakeholders. The virtual lab team at IIT Bombay, including the remote centers and nodal centers, work on the transparent system. This particular format has been developed by the two faculties, those who belong to the remote centers. Now, the name you can see at the bottom of this format, this will appear at all the time. So though this has been developed in 2020, but still it is going on and we are using it by the same name. So transparency is definitely maintained at virtual lab. So if you are contributing in any domain with any perspective of content development or any kind of suggestions, so that are welcomed by the team virtual labs. So you can target to have the mega outreach program, allotment of the nodal center by IIT Bombay, initial usage count at the allotted nodal center, outreach program can be conducted. Nodal centers faculty can contribute in virtual lab development and content development. Internship opportunities is available. Fully functional student coders group. Yes, we can target our students to work in a group for coding, that is content development. So it is not that only institutes students will work for that. IIT Bombay wish to have the multidisciplinary and multi-level involvement of the students. So students from your institute, other regional centers and other nodal centers can work in a group to have the content development. And in future, the nodal center can switch over by its performance to the new regional center. So this is how the team of virtual labs at IIT Bombay works on. So an institute can plan to map whole syllabus of all the streams in virtual labs. So that will be very much beneficial for the university if we distribute our content development group wise and plan to develop the virtual labs. So as I told you, we get the wide visibility. So Abhasi is the biannual newsletter published by IIT Delhi, who has initiated this virtual lab activity in the beginning. So it gives you the wide coverage. If your institute works on content development, either it organizes the boot camp, either there is the coders group and many more activities we are associated with. So you can see that the IIT Bombay has announced the Shining Nodal Centers, PVG Institute and the Maharashtra Institute of Technology, that is MIT Aurangabad. So these two institutes have been nominated as Shining Nodal Centers. So this is one of the achievement of both the institute. So wide visibility. But there is a question, what are the technical requirements so that we can set up a virtual lab at our institute? So nodal center setup requirement is designated common lab space has to be available with minimum 40 PCs and 2 Mbps broadband connection. Audio-visual facility with multimedia projector is essential. If internet operates behind the firewall, we need to take care about some specific ports like 3306, 5900, 5902 and 8700. Access to Gmail and Facebook should be available and Java should be in downloadable form. So already I discussed this responsibility at nodal center. So you are the interface between the outreach program and IIT Bombay. Execution of training sessions. You have to popularize the virtual labs, support for field testing the labs, testing and debugging of virtual labs. Monthly progress report needs to be submitted by the nodal center. Organization of workshop per semester is essential. Increasing the usage of vLabs, minimum to the 8,000 and maximum at your level can be think of. So technical skills for content development which is required for the students and faculties are student developer should have the knowledge of FOS resources such as TypeScript, HTML, Git, source code editor, sketching. And faculty developer can have the basic knowledge of resources such as MS Office, sketching and drawing tools and how the pedagogy contents can be written. So IIT team trains all the faculties and students for the content development. These are some of the virtual labs available at IIT Bombay. So you can visit here and some of the labs at the vlab.com. So I wish all of you to have the happy going with virtual labs and please come forward the students and faculties have a great potential to contribute the content development. So I request all of you to let us all contribute in nation building through the virtual labs community. Thank you. If you want, you can reach to Manager Virtual Labs IIT Bombay at this manager1@vlabsdev.in. Thank you.
Hello, I am Shravani, currently a third year engineering student at PVG COET and GK Pativani College of Management, Pune. I am a member of VLab Digitizers Forum since 2020. I am the technical head and mentor at VLab. I have developed experiments in robotics and medicine lab. I have served as a junior trainer at Bootathon Knockdown the Lockdown organized by Virtual Labs IIT Bombay. I have been certified for HTML, CPP, C, Arduino by Spoken Tutorials, IIT Bombay. Now, I would like to introduce Professor Manish Nagoshe sir. Professor Manish Nagoshe sir is an assistant professor in Department of Mechanical Engineering at Pune Vidyarthi Gruhas College of Engineering and Technology and GKPIM Pune. He is working as an assistant professor in Department of Mechanical Engineering and has a total work experience of over 22 years. He is nominated as the first regional technical coordinator in the country by IIT Bombay Virtual Labs. He is playing a key role to promote development activities across the country. He has developed around 50 virtual lab experiments for the fundamental subjects such as JavaScript, fluid mechanics, strength of material, analytics and synthesis of mechanism, numerical method, etc. He has been a part of 3 development workshops, 3 boot camps, 3 bootathon related activities where he has trained more than 800 students across the country. He has been training to college students of Forum VLab Digitizers, as a result of which students have developed 8 labs under his mentorship. He is a programmer and mentor of development of 13 labs. He has designed a framework which enables the programmer to develop lab in least possible time. He is playing a key role in development, collaboration, maintaining pipeline, automation testing and hosting virtual labs through various suitable technologies. He has received certifications of development of virtual labs by IIT Bombay. He is working as a receiver for new virtual lab development on VLab Dev, IIT Bombay. Over to you, Nagoshe sir. Thank you.
Hello everyone, greetings of the day. Thank you Shravani. So today I'm going to talk about the VLabs Day. So 2 major activities we are having under the VLabs Day. First one is the Bootathon, where the faculties and students participates to develop the virtual labs. Faculty will have different rounds and the student will have the another track. The faculty will go through all the pedagogical aspects, designing of experiments and so on. So there are total 6 rounds for students as well as the faculty, and each round is qualifying. After the completion of the training, then the process of development starts and the coding part will be taken by the students. So faculty may get students from various different colleges to design and develop the virtual labs. The student which performs better will also get an opportunity as an internship from the IIT Bombay. This is one of the forum under the VLabs Day at our college. We call that forum as a VLab Digitizers Forum. So currently 148 plus students from our college are working under this forum, and these are some of the students been highlighted on a VLabs Dev team page. please do visit this page. How this student forum actually works. So students from all disciplines basically selected through an interview process. So virtual lab activity is not limited to a specific branch, but it is a multidisciplinary activity, and therefore students from all disciplines are required. Each discipline's student will have a certain important role to play. The second year students who actually develops the virtual labs, does the documentation, and are the trainers to the students. Third year students are the project managers. They do a lot of internship. They train and mentor the second year student for various other higher level programming languages and the courses. These students are more important to develop new technologies, designing a new framework which helps the second year student to develop virtual labs. Final year students are called as VLab heads. They are basically to mentors to T students, and they are basically a resource person for the boot camp. So here one grade level opportunity the students get it. So basically in national level bootathon, these students works as a mentor and the resource person to conduct the national events. Basically they conduct all kinds of training in the bootathon. The projects which they do it under their leadership, third year students also get participated, so that the legacy from final year to third year to second year to first year continues. So the knowledge transfer do takes place as they are working cohesively together. So what kind of technologies the student are supposed to use in this to develop the virtual lab? That is one of the biggest question in everybody's mind. So we are using the most simplest technology, HTML, CSS and JavaScript. Of course, those technologies are simple, but we do require a specific and specialized knowledge in the HTML, CSS and JavaScript area. Recently we added the working with the TypeScript. So now we are not using a JavaScript, but we are using a TypeScript to handle the JavaScript code basically. The course which we have designed is also recognized as an audit course under the SPPU University syllabus. Most important aspect is the training given by the student for the student. So this forum is totally run by the student. My responsibility is to add the new content to this container, and this container grows on its own. It is open to all engineering disciplines. The technologies they studied right from first year to final year in these forums are listed as. So it starts with HTML, then various database technology, then various web-based technology like PHP, Django, various phone technology like Android, Java programming. Then they go with the Pythons for machine learning projects. So now the machine learnings are being introduced into a virtual lab, as well as this machine learning projects helps in their third year and final year projects. They are getting training like Arduino and Raspberry Pi for developing IoT applications. Various modeling softwares like SolidWorks, 3D Experience, they do study, and various analysis tools like ANSYS, Abacus, which they go through it. In this forum also robotics and courses related to artificial intelligence are conducted, which helps the student to go in all directions. Recently we have also introduced .NET application development, which students are studying and getting the benefit of those technologies. After such a rigorous work, it is bound to happen that these students get the better opportunity like internships, development of projects from the virtual lab, and various project opportunities related to internship is also provided by the IITB. This training basically helps the student to tackle internships and various projects, and which help them to grow in a more brighter way. As far as placement record for virtual VLab Digitizer Forum is considered, it's 100% placement every year. So being a part of student forum, it gives a massive advantage over the other student because of multidisciplinary activity. It inculcates confidence and various striking personality which are favorable to the various recruiters. These are the some of the highlights of the student project which I would like to mention. So VLabs outreach portal is been designed by the students of VLab Digitizer Forum. They are they have played one of the most important role developing these portals. They have contributed in development of Ergo Robot, EDU Robot, Quadcopter, Hexapod. The students of this forum has contributed and published international journal papers. It also helps me because they are also getting certification from various courses through IITB and various other organizations, and that helped me immense because to acquire the project from any bigger organization, that I do have a certified student in those specialized technologies. So Naho Bionic Arm and Mitra was a special project. Bionic Arm was sponsored by La Foundation France, and Mitra was one of the special projects in the robotics area. These are the some of the projects which I would like to show you.
Tell us something about yourself.
Absolutely. My name is Hector. I'm a board in the Conversation Lab of TVG College of Engineering and Technology. I am transport and transform your point device. Welcome to my home.
Power bank is of 10,000 mAh as it
Dance
powers
for
the
us.
Raspberry Pi and the motors through relay. We are using relay to control the motors from the Raspberry Pi, and its power is taken from the power bank. The Raspberry
There is a lot of achievement by the students of this forum. So some of the highlights I would like to read out. 6 students from our college completed internship at IIT Bombay and contributed to development of VLabs portal which is used nationwide. Currently 5 students are also working with now new and bigger portal with the IIT Bombay. 11 students from our college contributed to VLabs outreach portal. 3 students delivered the session on mind map at first national level bootcamp at Rajkot. 1 student was invited for the second national level bootcamp at Ahmedabad. 2 students was invited at the third national level bootcamp at Aurangabad. 20 students were invited as a mentor speaker for national Bootathon 1, 2, 3. 5 students received platinum certificate in Bootathon for completing their virtual lab within stipulated time. 8 virtual labs have been developed by the students. In all, 40 students are recognized as a developer. Now that number has grown to 55. Two teams participated in second boot camp and the one team participated in third boot camp. All of the team has submitted their projects. Students have achieved certification from IITB spoken tutorial in various technologies. 4 students successfully delivered the project from Dassault system where they make the bionic arm for the amputees. Students have received the funded projects from IEEE and other academic institutions. Students have developed and hosted Android app on the Google Play stores. So it is proud moment to say that till now date the highest package salary is offered to this student from this forum. And this is the photograph, and we call this as the team. The team is massive. Join virtual labs, stay connected with new thinking, new possibilities. Thank you.
Hello everyone, I'm Ronak Murray and I'd like to begin with a short introduction of mine. I'm a second year comms student at Pune Vidyarthi Griha College of Engineering and Technology. I've successfully completed the audit course for virtual labs and I've been a member of the VLab committee since around February 2021. I'm also a certified HTML developer by IIT Bombay. Going forward, I'd like to introduce Professor Tanuja Khatavkar. She is an assistant professor in the Electronics and Telecommunication Department at Pune Vidyarthi Griha College of Engineering and Technology. Khatavkar ma'am is a passionate teacher with about 30 years of teaching experience and is a Cambridge certified teacher trainer. She is nominated as the first regional virtual lab coordinator in the country by IIT Bombay Virtual Labs. The PVG's team under her leadership mentors about 58 virtual lab nodal centers affiliated to various universities in Maharashtra. More than 30 virtual experiments were developed by Khatavkar ma'am and the student forum are published by IIT Bombay Virtual Labs team and hosted on the VLab Dev platform. Khatavkar ma'am and her students team at PVG Squared bagged the Platinum certification at the first National Virtual Lab Bootathon at REC Bandhana, Uttar Pradesh in November 2019. Khatavkar ma'am has a remarkable contribution as a certified mentor slash viewer in the Virtual Lab Committee development model right from the 3 development workshop held at Pune, Mumbai and MSU, Broda, followed by the 3 consecutive national bootathons at Marwadi University at Rajkot, Gujarat University in Ahmedabad and MIT in Aurangabad. Following that, recently on 7th September 2021, ma'am was also awarded the most prestigious award of Adarsha Shikshak Puraskar by the International Association of Lions Club. I'd now request Khatavkar ma'am to say a few words.
Greetings to one and all. While working on collaborative projects, this quote by Swami Vivekananda strikes my mind. A nation is advanced in proportion to education and intelligence spread among the masses. Project Virtual Labs is an initiative of Ministry of Education under the National Mission on Education through ICT. Myself, Professor Tanuja Sachin Khatavkar, Regional Coordinator for Pune region from Pune Vidyarthi Griha College of Engineering and Technology and GK Patewani Institute of Management, would like to present the Regional Center success story. The Regional Center is affiliated to Virtual Labs IIT Bombay and is working in coordination with IIT Bombay for last 7 years. So I'll be giving you a brief overview of this success story of RCID 01 and NCID 20. That is Regional Center ID 01 and Nodal Center ID 20, which is affiliated to Virtual Labs IIT Bombay. I would like to quote here that PVG COET is the first regional center designated by Virtual Labs IIT Bombay in the country. Well, the journey started in 2015 as a nodal center. So in 2015 and 2016, we worked as nodal center, and based on the performance of the nodal center in terms of rollout and also an initiative of development of new virtual labs, the center was designated as Regional Nodal Center from 2017 onwards. So right from 2017 for next 2018, 19, 20, and even this year, we are the regional center affiliated to Virtual Labs IIT Bombay. Working with IIT Bombay, we took ahead the rollout program, that is VLab rollout program, to all types of colleges. They were private colleges, aided institutes, or university affiliated institutes. Some of them were actually universities or deemed institutes, or they had autonomous, or they were autonomous. We not only took rollout activity for faculty from different colleges, but also in association with IIT Bombay, we had a massive Nodal Coordinators Outreach Workshop pan-India. Another massive rollout is the Savitribai Phule Pune University Engineering and Science Technology, the rollout for these engineering colleges, and also the one which we are talking about is the Polytechnic colleges. The statistics for the workshop for Polytechnic institutes reveals that nearly 76% of the participants belong to Maharashtra, then 16% of them they belong to Gujarat, and 8% of the institutes or the faculty are from Tamil Nadu. Well, the cities to which these colleges belong to, these polytechnic institutes belong to, have been mapped in this particular graph. So here you'll observe that most of the colleges are from Pune. They are from Pune, some from Kolhapur, then you'll find some from Mumbai, and also we find colleges from Gujarat like Ahmedabad, Bharuch, Baroda, and on this side from Tamil Nadu, colleges from Tamil Nadu, they have participated in the Polytechnic workshop. Rollout was one of the factors that we took ahead in coordination with IIT Bombay. In addition to that, one step or 1 mile, we can say, we walked ahead and we took the initiative of developing virtual labs. So the development program began there. And we started with the journey of VLab Dev with IIT Bombay for the community development. This journey started with 3 pilot workshops, right? And these pilot workshops were conducted at PVG's Pune, then MSU Baroda, and also at VIT Mumbai. The boot camps, following this, we had the boot camps. The first boot camp we had at Marwadi University, the second boot camp we had Gujarat University, and the third boot camp we had at MIT Aurangabad. So you will find there were 3 pilot workshops where we tried on a very small scale, let us say 30 participants, and we worked out this endeavor of development of virtual labs and observed the feasibility of development of virtual labs from the community, from different private colleges or different universities coming together in a collaborative mode and developing the virtual labs. The success of these 3 pilot workshops gave us the confidence of going for larger scale workshops such as boot camps, wherein people from other colleges from Gujarat, that is Marwadi University, then Gujarat Technical University, and MIT Aurangabad, they came ahead and they hosted these boot camps where PVG COET faculty and students, they worked as resource persons, mentors, and reviewers along with IIT Bombay team and the other regional teams. This development program, it did not stop here. It was also conducted as a bootathon later in REC Banda, Uttar Pradesh. Boot camp plus hackathon is bootathon, right? So we had the first bootathon in Uttar Pradesh somewhere in around November 2019. And here, during this bootathon, the last phase of that bootathon, we had it in the online mode actually because of certain reasons. The KTL1 and KTL2 are the knock down the lockdown Bootathon 1 and Bootathon 2, which were conducted during the COVID period in an online mode. These development workshops were not only conducted to explain the pedagogy and the storyboard that has to be designed by the faculty who teaches the subject, but also had the training programs for the students where they learn the technologies that are required to develop the virtual labs. Now, to enable students to come up or to equip them with the technologies to develop the virtual labs, Web Development National Level Program was conducted by PVG COET. The beauty of this program was students from first year who had taken up this course of web development, who had taken the training, they conducted this workshop for students all over India, we can say, because we had a massive participation of more than 6,000 students had registered for the event, and more than, and I can say 3,500 students were actually certified for this program. The regional center at PVG COET has ensured the students' fruitful engagement through this portfolio of virtual labs. So if we just look at this chart, the participation and the mentoring that the students have done at different workshops, you'll find that the first pilot workshop was initiated by PVG COET, then followed by Thane, VIT, Vidyalankar Institute of Technology Thane, and MSU Baroda. These were the first 3 pilot workshops that I was talking about earlier. So that time we had one team from PVG which participated for the development of workshop under the mentorship of the faculty in the college. Then we had the first national boot camp at Marwadi University, Rajkot, somewhere in February 2018 in Gujarat. This was the first national boot camp where the students, 3 students, they gave sessions on mind maps, how to create mind maps for the virtual lab that the faculty are going to develop. So the students, they gave an online mind map session to faculty who had participated in the national boot camp at Rajkot, Gujarat. In the second national boot camp, which was conducted at Ahmedabad in Jan 2019, we had one student who was invited as a student mentor for the program. And in this boot camp, we had 2 teams who participated for the development of virtual labs. Following this, in February 2019, immediately we had the third national boot camp at MIT Aurangabad. In this, we had 2 students who mentored the students from different colleges to develop the virtual labs, and 2 teams from PVG COET participated in the boot camp. So we had 3 pilot workshops followed by 3 boot camps. The success of these led us to the next version of the boot camps, that is bootathons. So the first national bootathon was held at REC Banda, Lucknow in Uttar Pradesh in September 2019. So here again, other two students were invited as student mentors, and one team participated in this bootathon. Well, it gives me immense pleasure to mention that this group of students, they received the platinum certification in this event. During COVID-19, when everything was under lockdown, we ensured through virtual labs that the students would be effectively engaged. And this was possible just because of the support of Virtual Labs IIT Bombay team and the management of Pune Vidyarthi Grass College of Engineering and Technology and GKPIM Pune. The next two bootathons, which were called the Knock Down the Lockdown, that is Bootathon 1 and Bootathon 2, they were conducted in April and May 2020. During this program, nearly 11 students were certified as senior trainers by VLabs IIT Bombay, and 8 students were certified as junior trainers. During the next bootathon, that is the second bootathon, we can say, 14 students were certified as senior trainers and 24 students were certified as junior trainers. So during COVID-19, faculty from different institutes, they had participated in this bootathon to come up with the pedagogy, the storyboard for the experiments they would like to develop, and the students from PVG COET, they took up the mission of translating these pedagogies and these storyboards into interactive simulators. Hence, they were certified by IIT Bombay as either senior trainers or junior trainers. Not only the students were effectively engaged, but even the faculty, they contributed effectively during COVID-19 lockdown. This gives me immense pleasure to mention the participation of the students and the faculty from the regional team for the Virtual Labs project. So for 5 colleges, the outreach workshop in online mode was conducted in May 2020. This was the first time that the outreach workshop was conducted in online mode. Following that, we had a webinar series for faculty of Abdul Kalam Technological University, Uttar Pradesh in May 2020, where faculty from the regional center, they demonstrated and explained the virtual labs to the faculty from AKTU, Uttar Pradesh. The KTL Bootathon was the event which was conducted during COVID-19. During this, the faculty from regional center, that is PVG COET and GKPIM college, were assigned or were selected as mentors and designated as reviewers for the labs being developed by the new proposals or new proposers. Following that, we had a massive outreach workshop for the faculty of Savitribai Phule Pune University in July 2020. And following that, we had a virtual labs outreach for the coordinators which are associated with IIT Bombay. Nearly 240 nodal centers with IIT Bombay. We had a workshop for all these 240 nodal centers, in association undoubtedly with the collaborative efforts of different regional teams associated with IIT Bombay. Well, we have one more program there, that is internships with VLabs Dev, IIT Bombay. This is another avenue or opportunity for the students to work with IIT Bombay team. So in 1819, nearly 6 students completed their internship with VLabs Dev team in June to September, during the duration of June to September 2018. And the outcome of this is the development of the VLabs Dev portal, which is used by all the nodal coordinators which are associated, or the nodal centers which are associated with IIT Bombay. Right now, 6 students are pursuing their internship with VLabs Dev. As I mentioned earlier, on 17th and 18th July 2021, a national level 2 days workshop on Introduction to Web Development was organized by the regional team at PVG COET by the students of the Digitizers Forum of PVG COET. And the outcome of this particular program was a participation of 3,500 students and faculties from India whose assignments they were evaluated and they were graded by the team and they were certified. This program was totally conducted by the students of first year engineering of the Virtual Labs Digitizers Forum at PVG COET. These are some of the publications. You'll find that the faculty and the students at PVG COET, they have come up with around 13 virtual labs like numerical methods, digital applications, network theory, digital logic design using gates, integrated circuits, introduction to PHP, computer graphics, introduction to JavaScript, material testing, analysis and synthesis of mechanisms, strength of materials, and fluid mechanics. You will find they are from different disciplines. So faculty from different disciplines and students from different disciplines, they work together in a collaborative mode. So it's basically a multidisciplinary type of assignment, you can say, multidisciplinary type of project on which students from different departments, faculty from different departments, they come together and they develop the virtual labs. Now let me share with you the outcomes of this program at PVG COET. First outcome is a massive rollout of virtual labs. More than 13,000 students and faculties have been trained to use virtual labs, and a usage of experiments, that is performance of experiments of more than 1 lakh has been performed alone at PVG COET through internal in-house programs as well as the outreach programs. Regional Center PVG COET could successfully establish around 60 nodal centers in Maharashtra. So various nodal centers from different parts of Maharashtra, especially the west zone of Maharashtra, except Mumbai and Aurangabad, we could identify potential colleges as nodal centers. As I mentioned, 13 virtual labs were developed by the faculty and students at PVG COET and GKPIM, which include more than 113 experiments. So the e-content development was to a very high extent created from the regional center of PVG COET. One of the best outcomes of virtual labs portfolio is the establishment of Virtual Labs Digitizers Forum, that is a student club, somewhere around 2016-17 at the center. More would be spoken about the Digitizers Forum by the Regional Technical Coordinator of PVG COET. In addition to this Digitizers Forum, wherein trainings for different technologies were given by these students to the students. So it was a peer learning type of activity. So senior students who were earlier trained by a faculty, they train the next batch of students in the VLabs Digitizers Forum. So the concept of peer learning, multidisciplinary learning, leadership, coding skills, all these were established through this forum called as VLabs Digitizers Forum. In order to equip the students with proper technologies, the first training through spoken tutorial certifications was also done in the college. Yes, as I mentioned, technology training was one of the important aspects where students worked with HTML, they worked with different technologies, and they were trained by the peer teams in the VLabs Digitizers Forum. One of the most important outcomes is the creation of virtual labs. So virtual lab content creation is one of the important outcomes of this virtual labs program. Yes, undoubtedly the skills of the students, there's an upgrade of the skills in the students, the coding skills, the soft skills, the interpersonal skills, then the communication skills, collaborative efforts, working in collaboration, peer review, peer learning, all these skill sets are actually sharpened when the students be a part of virtual labs. So one of the outcome which we can look at is a pool of collaborators and peer learners was created at PVG COET. As I mentioned, internship opportunities and resume building and mapping of the resume with the job descriptions is yet another outcome which gave them more networking and also got good jobs for the students who have passed out of the institute. In this success story, I would like to also share some accolades. PVG COET and GKPIM is the first private unaided institute to develop virtual labs in the country under vLabs IIT Bombay. It was declared the best performing shining nodal center by the Abhasi MHRD vLab newsletter 2018 and 2019. As I mentioned earlier, for one of the labs that is digital logic design using gates, it was awarded the platinum certification during the Bhutathon at REC Banda, Uttar Pradesh. So such accolades and many personal student, individual student accolades are available at the regional center. Well, these are the two links that you could use to access the virtual labs. We can help you to become a nodal center. You can reach us at vlabs@pvgcoet.ac.in. The colleges who would like to be a part of the virtual lab program and would like to perform as nodal centers and take the virtual labs to the grassroots level, PVG COET team, being the regional center, can help you to bring on board as nodal center. So kindly send your emails to vlabs@pvgcoet.ac.in. Yes, at the end, I would like to give my special thanks to all those people who made these accolades achievable. I thank the management of Pune Vidyarthi Grihas College of Engineering and Technology and GK Patewani Institute of Management for giving us the strong support to work on this project of virtual labs consistently for last 7 years. Thanks from the entire team of vLabs at PVG. I thank Dr. Santosh Naruna sir, the principal investigator for virtual labs at IIT Bombay. I thank Pushpadeep Mishra sir and Jay sir, the senior project manager and project manager at vLabs IIT Bombay, for giving us multiple opportunities for the students and faculty to take ahead virtual labs to bring all these accolades to the institute. Thanks to all the faculty and students, and thanks to the community, all the engineering colleges, the polytechnics, all the faculty and students who have been a part of virtual labs community for giving us different opportunities to work with them in collaboration. Thank you. Thank you all.
Hello everyone, I am Vaibhavi Mekhe from PVG COET and GK Patewani Institute of Management. I will give a quick introduction about myself. I am third year student pursuing computer engineering degree at PVG COET. I am a member of vLabs Digitizers Forum since 2020. I am currently a mentor in vLabs Digitizers. I have completed audit course of virtual lab. I am certified by IIT Bombay for Python, C++ and HTML. With this, I would like to introduce Honorable Shri Pushpadeep Mishra sir. He is project manager at Virtual Labs IIT Bombay. He has played a key role in outreach development and community engagement for vLabs. Sir believes in work at grassroots level, which mainly involves interacting with students and teachers and identifying problems and challenges faced in academic study. Sir's main focus has been on content development for virtual labs. With this, I request Honorable Shri Pushpadeep Mishra Sir to say few words.
Hello everyone and welcome to the workshop, the outreach workshop for Polytechnics on virtual labs. I believe that you had a day-long session already learning about the fundamentals of virtual labs, the concepts behind it, the idea behind creating virtual lab, and some very good demonstrations by the regional coordinators and the nodal coordinators from various regions. So by now, I think it must have been very clear to all of you that outreach is a very essential part of virtual labs. It is important so that the dissemination of the virtual labs, the information is passed on to the academic community, to the students and instructors. Well, as you know that from the previous talks also, you must have learned about that virtual labs was started long back, a decade before, back in 2010. And by 2014, we had a myriad of content available online. But there was no visibility which was required. So Ministry of Education, or formerly called as MHRD, the vision was the government had at that time is to provide quality lab education alternative, an online digital alternative to the engineering students. Well, so the only way this could have been done is to have a very strong outreach program. Way back in 2014, all the consortium partners, the IITs and the premier institutes, we started the journey of outreach. And I still remember that we used to go travel physically to locations in the remotest part of Maharashtra and other western India, and go and interact with the students, with the instructors, understand the ecosystem, the academic setup, the challenges and the issues faced, and that helped us to groom the outreach program in a better way. So, so it is now that it has matured to a level that the outreach program held by IIT Bombay is going very strong. Right from the west of the western part of the country and the northern part, so Jammu and Kashmir, is totally covered by IIT Bombay. We have more than 300 nodal centers who are continuously helping us to reach out to this virtual labs concept to the community, the students and instructors. And so let me tell you that we have more than 2,000 workshops so far with help of our partners, and we call them as a nodal center. So a nodal center is therefore a very important, plays a very important role in this outreach program. And for IIT Bombay, every nodal center is very important. And about this nodal center, the centers who have achieved excellence in the outreach program, they become the regional centers, and regional centers, they work very closely with IIT Bombay. They're helping us to reach out to various colleges across the country. So the outreach program is built in a way that it spreads across within various departments within your institutes, and it kind of gives a flavor of how the digital content can help to enhance the quality of learning to the students. So virtual labs has been fundamentally built for the engineering fraternity, but as you know that polytechnics have very good foundation, and they many of them actually they come and join the engineering disciplines, engineering degree programs, and a lot of hands-on experiences. In fact, at a very early stage, is taken by the polytechnic students. So there, we feel that virtual labs has a huge scope to penetrate and help the academic community. Well, for that we need your help and support. Well, by the way, all the speakers that you had today were at some time back, they were just faculty working, constantly to help students, just like you, all of you. Uh, but they took an initiative that they will put in extra effort and help IIT Bombay to roll out this virtual labs program within their department and also within their entire institute. So once you're a nodal center and you're a nodal coordinator, the responsibility of spreading the virtual labs is across the across your institute, not just your department or to your students. So all of the speakers today, which we had, we call them as leaders. We don't they are not just nodal coordinators for us or regional coordinators for us. They have been actively helping us in crafting this outreach program. The way semester is planned, syllabus gap is filled before the semester starts, and the mapping of what is to be, which virtual labs is to be given to the students with the team of department coordinators. So all this process, including the feedback of the workshops and submission of reports, all of this has come from the speakers which were which held the sessions for you today. So what I mean to say is that we actively engage with the nodal centers. So it all depends on how much effort you take. The more effort you take, the better support you also get from us. So it's a mutual benefit that we get from spreading the virtual labs. So after today's day-long sessions, I'm sure that many of you must be moved and motivated to take this virtual labs concept to your polytechnic institutes, for which you can reach out to your nearest nodal center or to the speakers and the organizers of these workshops today, and you can express your interest to become a nodal center. It is very important first to, once you become a nodal center, to first map your syllabus with the list of experiments that are available currently on virtual labs platform. As I told you before that, these are fundamentally meant for the engineering curriculum, but there is a lot of overlap between the polytechnic and the engineering domain. So I'm pretty sure that a lot will be common to your students and your academic community. So once you become a nodal center, as a nodal coordinator, you take the leadership and form inter-department network, assign department coordinators, have meetings with them, chalk out the plan. We call this as a planner. So you prepare a planner semester before the semester begins. That what activities can be taken for the students in the semester with virtual labs. Once that is done, then the task becomes pretty easy, because now you are not just alone as a coordinator to execute this program. You get the support from the various department heads. May not be a head; they can be any active faculty, and we have seen that institutes who have followed this model have benefited to a much extent In fact, they have grown and reached to a level of regional center. So, and then engage with your students, understand what is that they need, take their feedback, and share with us. You do connect with us and your regional centers, and we look to have engagement with you beyond just the outreach program. But outreach is the very first thing that is important, because unless and until your colleagues and your students do not understand what is virtual labs, and the only way to do is to hold workshops and such activities. So unless that is done, it is very difficult to go ahead and try out something else. So as Professor Narona in his talk mentioned about the innovation and other such things that we have in a pipeline. So there's a lot waiting for you beyond this outreach sessions. So we hope that we'll get your active support. Do reach out to us, express your interest to become Nodal Center, engage with us, engage with your students, share your feedbacks, and let us make this program a huge success for the Polytechnic as well. And this all starts with efforts from you. And feel free to reach out to us for any kind of support. So once again, with that, I thank all of you for giving your time and attending this program. And we hope to get your continued support in days to come. I thank all the organizers and the speakers who were there for this day, and all the support people from the right from the student community and the academic community and the teachers community who have helped organize this program. I also thank on behalf of Professor Narona and my team, Virtual Labs at IIT Bombay. And yeah, thank you and have a good day.
Hello everyone, my name is Anushka Khuspe, and to begin with, I would like to give a short introduction about myself. I am a second year engineering student at Pune Vidyarthi Grihas College of Engineering and Technology and GKPIM Pune. I have been a member of the Virtual Labs community since 2021. I have also been certified by IIT Bombay for HTML. I was one of the resource persons for the Web Development National event held by PVG CUET. In addition to this, I had participated and secured first place in Front-End Web Development Hackathon 2021 held by ECEL IIIT Pune. Now I take this opportunity to introduce Professor Ajit Narendra Gedam Sir, who is a lecturer at the Department of Computer Engineering. Sir has completed his bachelor's in computer technology and master's in computer engineering, specialization in computer networks. He has a teaching experience of 17 years. His publications in international journals include a paper on hybrid crypto system approach using secure intrusion detection system, secondly a review paper on preventing forced acknowledgement, and thirdly a paper on centralized secure routing protocol for mobile ad hoc network. His publications and conference include Property Evaluation System, Multi-Platform Car Game Controller and Driving Simulator, Anti-Theft Mobile Tracking System, System to Identify and Define Security Threats to the Users, about the illegitimate installed applications, and lastly, Image Watermarking using QR code. Book published is Relational Database Management System by Vision Publication in 2010. Sir has also attended various workshops and courses such as Ethical Hacking and Information Security, Linux Basics to Applications Clustering, 4G Technology, Research Opportunities in Distributed Computing, Network Simulation, etc. Sir's professional membership include Life Membership of Institution of Engineers India, Life Membership of ISTE, Faculty Advisor IEI Students Chapter, Secretary cum Treasurer ISTE Faculty Chapter, and VLAB Nodal Coordinator. So special achievement include he has been nominated for election of 3 representative All India Students Committee AISC in 2018 to 19. He has also been nominated for the election of the 3 representative AISC in 2019 to 20 for Maharashtra State. CWIT invited him as a chief guest on 20th November 2019 for IEI Students Chapter inaugural function. Recently nominated, and he has been contesting election of IEI Local Center Pune, which will be held between 26 September 2021 to 25th October 2021. With this brief introduction, I request Sir to say a few words.
Good afternoon, one and all present here, honorable guests, respected dignitaries, and dear all Polytechnic faculty participants. It gives me an immense pleasure to take this opportunity to propose a vote of thanks for this outreach workshop to dignitaries assembled here, and would like to thank our chief guest, Dr. Santosh Naroha, Principal Investigator, Virtual Lab IIT Bombay, Shri Pushpadeep Mishra, Project Manager, Virtual Lab IIT Bombay, who honored this outreach workshop with their inspirational thoughts and knowledge. I take this opportunity to especially express deep regards and gratitude to the Virtual Lab regional coordinators, Professor Tanuja Kataukar Madam, who take this initiative for organizing such a wonderful workshop for the Polytechnic faculties. I would like to thank all the resource persons from various regional center, MSU Baroda, MIT Marathwada, DYP Navi Mumbai, who explained the virtual lab experiment very well. I would like to thank to all the nodal coordinators to take step for this community efforts of rollout virtual lab to the faculties of all disciplines of Polytechnic institutes. I would like to thank all the principals from various Polytechnic colleges, faculty members, participants, and last but surely not the least, I thank you all, technical support team, for helping us webcast and streaming this event through YouTube channel, making this outreach workshop grand success. Once again, I thank you all for being with us this afternoon. Thank you. Thank you all.